SQL or just Postgres is one of the most popular relational database management systems on the market. It supports both SQL for relational and JSON for non-relational querying of data. Approximately 6,000 companies reportedly use Postgres SQL in their tech stacks, including Uber, Netflix, and Instagram. One of the major benefits of Postgres SQL is that it's free and open source. It is also supported by all the major operating systems and supports multimedia and text based data querying. Let's jump directly into the agenda for this video. We'll start with understanding what is Postgres SQL. We'll also understand how do you install Postgres SQL on your systems. We'll understand the concepts of Postmaster and physical database architecture. Moving ahead, we'll build a sample data directory layout and understand what are database clusters. At the end of the video, we'll be discussing what is query planner settings, and by the end of that, we'll perform a hands-on for the same. So that's all for the agenda. Now let's start with our first topic.
Before we begin, don't forget to subscribe and press the bell icon to get latest updates from Intellipaat.
Welcome to today's tutorial, guys. For today's topic, I'll be talking about PostgreSQL.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
The agenda for tutorial will be two topics. So firstly, I'll be introducing what is PostgreSQL. Then I'll be moving ahead with the installation of PostgreSQL. Introduction to PostgreSQL. PostgreSQL is an advanced object relational database management system (DBMS) that supports an extended subset of SQL standards. That is, PostgreSQL is a database engine which supports already established SQL standards, which includes transactions, foreign keys, subqueries, triggers, etc. So in order to run an SQL command or an operation, you need two things basically. One is a database engine or a server, and the other thing is graphical user interface. You can also type out your, do your SQL commands or operations in the command line interface, but as most of us use graphical user interface, we'll be going ahead with the GUI. So examples for a database engine or server will be MySQL and then PostgreSQL and then Redshift, which is a service from Amazon Web Services. The most used database engine is MySQL, and its corresponding graphical user interface is MySQL Workbench. But nowadays, PostgreSQL is catching up to MySQL, and PostgreSQL is typically used for data analysis and data warehousing applications, and its corresponding graphical user interface is pgadmin. And for Redshift, you can use any third-party graphical user interface like PopSQL. Looking at the companies using PostgreSQL, we have Instagram, Netflix, Spotify, Uber Technologies, and then Reddit. All these trending companies are using PostgreSQL nowadays. So it is better for you to learn about PostgreSQL and become familiar with the user interface. Now let's see what PostgreSQL has to offer. PostgreSQL is a completely open source engine, which means all of its source code is available for everyone to see, manipulate, and use. So you don't have to pay any subscription fee like other database engines. And the second thing is it is complete ACID compliance. ACID properties for a database management system is a must. That is a standard that is followed by every database engine. So PostgreSQL follows this as well. And the third thing is it has a comprehensive documentation and active discussion forums. So when you go to the PostgreSQL website, it has a 3,500 page documentation, and you can see all the commands and the syntaxes for each commands there. And on top of that, even if you have further doubts, there is an active discussion forums where you can type in your questions, and your questions or problems will be solved very quickly. And the next thing is PostgreSQL performance is utilized best in systems requiring execution of complex queries. As we all know that data analysis and data science uses complex SQL queries, which has to run huge amounts of data. So PostgreSQL is optimized for big data analysis. And PostgreSQL is best suited for data warehousing and data analysis applications that require fast read and write speeds. And whenever if you want to read or write within the database, so that transaction speeds are more in PostgreSQL. That is, they have optimized PostgreSQL for read and write speeds. And the last thing is, it is supported by all major cloud service providers like Amazon Web Service, Google Cloud Platform, and Microsoft Azure. So you can say that since it supports all the major cloud service providers, that it is future proof. PostgreSQL is future proof because it is supported by cloud service providers. Moving on to installation, you need to type the URL www.postgresql.org. It will take you to its homepage. Now it is asking you to download either the package, the whole package and the installer, or the source code. It is better to go for the whole package itself. So I'll be choosing my platform, that is Windows. You can choose Mac. You can choose whichever platform you are running. And then you need to click on the download the installer button. So I'll be my system is Windows 64-bit, so I'll be downloading one of these version. So it is better to download the 10.18 version since it is a stable release and it does not have it support other platforms as well in case if you're using other platforms. So it is better to download the Windows 64-bit and 10.18 version. So I'll click on download. Now I'll be skipping this part until the download is complete. Now I'll be clicking on the executable file. Just give admin access to the application. Now, if since PostgreSQL uses Microsoft Visual C++ in the background, it will prompt you to. I mean, it will default by default. It will download the Microsoft Visual C++. If your system is already, if you have installed the C++ already, so it will skip this part. Now, after the Microsoft Visual C++ 64-bit version is installed, this window will pop up. So you need to click on Next. This is the setup wizard, and it will ask you for the installation directory. Choose the location you want to download your file, and then click on Next. So it is asking you to basically this comes with 4 components, that is the PostgreSQL server, and then pgadmin 4, which is the graphical user interface for the database engine, and then stack builder. You don't exactly need this for beginner practice, but you might want to need this in the future, so just keep it on check. And CLI tools, just click on next. Please select a directory under which to store your data. So this let it be the default, or you can choose your directory. And you need to set up a password for your database engine, that is which is a local host in your case. So remember your password because this will be asked when you want to access your database. And let the port be on default. Let this be also default. Click on next. And this is your preview which you have set up. So check it once. This will be your installation directory, port number, etc. So if any changes, you can go back and make your changes. If not, just click on next. Click on next. So it will take a while to install the 4 components, that is all the packages. So I'll be skipping this part until the installation is done. After the installation, you'll be shown this setup page. Complete the post. You need to uncheck this and then click on finish. Now you can search for pgadmin 4 in your search button, or just click on the shortcut key wherever you have downloaded it. Now pgadmin 4 is not a standalone application. So it is basically, it will open in your default web browser. So it is basically a web-based user interface. So now you're prompted to type in your password that you created while installing the packages. So when you type in that password, you'll be granted access to the database. So this is your dashboard, and when you click on server, it is asking me the password again. So I'll just type in the password. So Postgres is your default database. You can create your own database if you want. And these are all the features that are provided in PostgreSQL, that is cast, catalogs, event triggers, extensions, foreign data wrappers, etc. So it is a very feature-rich database management system. So now if you want to write SQL queries, you can just click on this tab, or you can just right click the database, and then you can just click on query tool, which will open up query editor, where inside which you can write your queries. Yeah, and that's it, guys. You can create another database and start creating your own database, or import a database from another file and then start writing your queries here.
So we are starting with the Postgres architecture. So I think if you are all familiar with any other databases and Postgres also, okay, so maybe you are aware of this, so but still. So we'll go through the basic, what are the major Postgres server components, okay, so memory level, okay, so background process level and the storage level, okay. So the picture here you can see, okay, so we have the Postmaster, shared memory, and these are some background process, and these are some files, okay, which are part of the Postgres. Okay, so I'm not sure, I'm basically an Oracle guy. So if you want me to relate with the Oracle, so I can do that. Okay, so if it is easy for you to understand with the correlation with any other existing databases. Okay, so basically, okay, Postmaster is the main process actually. Okay, so this process is the first process which will be started when you start the Postgres server. Okay, so when you start the Postgres server, so we have a shared memory allocated. Okay, so for your database, and in addition to that, there are some background processes. So there are around 6 background processes that will be initiated. Okay, so and then so there are the storage files. So main storage files here in the Postgres is data file. Okay, so and we'll discuss the other part of the files. Okay, so this is about the starting sequence of the Postgres. And obviously, as other databases, Postgres database also has one configuration file, okay, for complete cluster. So where you can define, okay, so how much memory you need. So it's completely a database configuration part, okay. So that is the main file, so which is read by the Postgres initially to allocate how much memory it needs and what all the different components. Okay, so we'll start with the different memory components. Okay, so when you initiate a connection, okay, so the first process which will take the connection is the Postmaster process. Okay, so that is the initial process. Okay, so when it comes to the Oracle, okay, I'm not that much familiar on the SQL Server side, probably how the connection happens, but when it comes to the Oracle, okay, so you may be familiar, like listener process will be there in Oracle. So listener process is responsible for taking the incoming request, okay, and then handovers that request to the server process. So here Postmaster process initially takes the request, and for every session which connects to the database like Postmaster, so it will spawn one more process. Okay, we can call a server process or Postgres server process, and that process is responsible for, okay, completing whatever the request that has come from the client. Okay, so here, okay, so that is the initial step, and like once the connection comes, so the parsing phase, okay, so will happen. So right from like syntactical check and checking the semantics, and then preparing the plan for your statement. So everything will be done initially, and then it will go to the execution phase. So that's the first thing. Okay, so and that happens on every database, right? So if you are already familiar, it may be Oracle, it may be SQL Server, it can be anything. So the parsing phase is definitely, and these are the few things which happens, right? Syntactic, semantic, and it prepares on the plan, okay, for your statement. Okay, so next phase is, okay, so we have three types of main memory components in Postgres. So you can see here shared buffers, wall buffers, and process array. Okay, so shared buffers is the memory where actually whatever the data is requested, okay, so that data is copied into this memory component, the shared buffers. Okay, so the main storage of all your data will be in the database files. Okay, so initially, okay, so whenever you request the data, so the data is copied from the data files to your shared buffers. Okay, so and as you know, like Postgres also supports the block, okay, or in Postgres terminology we call that as a page. Okay, so the default, or I can say most of the cases I saw, okay, so the page size we use is 8 KB, but it is possible to use the other page size also. Okay, but I see most of the cases people use the default page size 8 KB. So that's the default page size. Okay, so in that quantities only the IO will happen. Okay, so whatever the data you request, so that data will be stored in the data file, and the smallest storage unit is the page. Okay, so in 8 KB page, the data will be stored. And from there, okay, so as the data comes, okay, the pages of for that particular table will be increased. So once the page 8 KB is full, then it will go to the next page and next page. So like that, it keeps on occupying the pages from the data files. Okay, so here, okay, so the data is retrieved from the data files to the shared buffers. Okay, and also, so here you see, okay, so this is not a single way traffic, I can say. Like it's not just the data goes from data files to shared buffers, because it may happen only for your select statements or read statements, I can say, right? So, but in case, what happens if it is a DML statements? So the DML statements, okay, so the changes will happen in the shared buffers first, and then it will be pushed to the data files. Okay, so that's the reason why. So you see here, it's not just that the flow of the data is not one way. Okay, so it's in the multiple, I mean, two ways. So there is a background writer. Okay, so this background writer, so you can see here BG writer. So these are background process we call. So this part is memory and this part is the processes. Okay, so and each process is responsible for a specific activity. So one of the process is background writer process. Okay, so this process is responsible for, okay, writing the changes from the shared buffers to the data files. Okay, so we usually call as dirty pages or dirty blocks. Okay, so those will be copied on over to the data files. So whenever they change or whenever you do a DML changes or DDL changes. So that's the initial mechanism of statements when you run. Okay. Next, coming to the wall buffer. Okay. So wall buffers, I think, is same like in Oracle, it is redo logs, and I think in SQL Server, it is transaction logs, I think they say. Okay. So what are the changes happening on the database? Okay. Those changes, okay, will be recorded in two memory components. One is in the shared buffers, and also in addition to the shared buffers, that also will be recorded in the wall buffers. Okay, so wall is nothing but write ahead log. Okay, so the full form of wall. Okay, so here the changes are written to the wall buffers, and here there is a one process called wall writer process. This is one of the background process. This process, wall writer process, is responsible for copying the data from the wall buffers to the wall segments. So this is again the storage. So, and here you see there is only one-way traffic. Okay, so wall buffers, you won't get the data from wall segments to wall buffers. You only get the data from wall buffers to the wall segments. Okay, but whereas in the shared buffers, so the data flows from buffers to files and files to buffers. Okay, so and obviously, so the functionality of the transaction logs in the SQL Server and the redo logs in the Oracle, the main purpose of those files are for recovery purpose. Okay, so it's not used when you run the queries, okay, normal select statements. So if you just read the statements, these buffers, wall buffers and wall segments are not used. But when you run any DML and DDL, then only these components will be used. Okay, that to write. Okay, so it won't read actually. So the read comes from the data files itself. So write ahead log. So the name itself represents, okay, so before the data is written to the data files, okay, the data should be written to the wall segments. Okay, so it's not like the data first is written to data files, then wall segments. It's not like that. So Postgres will confirm that it must be written the data to the wall segments, and then only the data should be written into the data files. And everything like checkpoint, everything is there as usual. Okay, for every certain frequency. Okay, so you have the checkpoint which pushes the dirty buffers from shared buffers to data files. Okay, so that's one of the thing which happens as usual in any other databases. Okay, so and wall segments are like they will be overwritten, or I can say they will be replaced. Okay, so in Postgres, I don't think maybe this is related to anything for developers, but it may be related to the administrators. Okay, so you have a few settings where you can set like certain number of wall size should exist. So then once that size reaches, so then it will just overwrite or remove the older wall segments, and then it will start generating the new walls. So that's how it happens. Okay. So to preserve the wall segments, okay, you have the archiving. So you can enable archiving on Postgres database so that so you can copy these wall segments. So the background process, okay, the archiver process you can see here. That is one of the process, okay, so which is responsible for copying the wall segments, okay, into some archive location. Okay, so basically these wall segments will be automatically overwritten or cleaned up after certain threshold, like whatever the size you configure. Okay, and but when it comes to the archives, okay, so that's not like automatically deleted. So you have to manually take the backups or whatever you need. So you can clean up directly, or if you need a backup of archives, you can take the backup and you can clean up the archives. So this is also basically required for the media recovery. Okay, so wall segments and archives are always required for recovering your database in case of any crash. Okay. So that's the three main types of files, and we have error log files, so where you can see the complete database log files. Okay, so there are a few settings for that again, so that's one type of file. Next is auto vacuum, so which is very important process, I can say. Okay, I think you already working in Postgres. You started working in Postgres. So Postgres is a auto commit database, first thing. Okay, so unlike Oracle, so Oracle is not by default not a auto commit database. Okay, so what is auto vacuum basically? So we have a concept called multi-version concurrency control. Okay, so what is mean by MVCC? So it's a very popular topic in Postgres. Okay, I think you know about the consistency of the data internally, right? So whenever you make any change or DMLs, okay, so how the data consistency is maintained in the database. So every database has a different kind of technique, but overall it will be it should be same. Okay, so to come to the work of the auto vacuum. Okay, so in Postgres, okay, so I'm not sure about the SQL Server, but in Oracle, so let's compare to Oracle. Okay, so when you go to Oracle, okay, so especially when you do an DML activity, probably update and delete. So not insert. So we don't bother about insert. So let's go with the update and delete. So when you update, so what happens? The data will be whatever the new value is there, that is updated. Okay. When it comes to the delete, the existing row will be deleted. Okay, so when you delete, so what happens, it makes some free room for any new row which comes. Okay, so then the new row can occupy the space which is created by the delete statement. Okay, and update. Okay, so usually it occupies the same row. Okay, whatever the row is there, just the value is changed, but it still exists in that particular physical location only, right? But in Postgres, when you do an update, so what exactly it does in the background is, okay, so it will insert and it will delete. Okay, so it will insert the row and it will delete the old row. It means it creates a new row when you update. Basically, it creates a completely new row with the whatever the value you changed, and the old value or old row, it will mark that as a dead tuple. Okay, we call that as a dead tuple. Okay, and when it comes to delete, it actually will not remove the row. Basically, it just marks the tuple as a dead tuple. Okay, means the row still exists in the file or in the table. Okay, in the table it does not exist. Maybe I can say, I can put in the other way. In the file, that row still exists, but it just flags that row as dead tuple. So there won't be any space created with that. Okay, so if any new row you insert, it cannot occupy that dead tuple space, because basically it's not creating the space. It's just making some flag like it's dead. Okay, so when you're doing like so much of updates or so much of deletes, okay, so there is a lot of dead tuples in your tables. Okay, so if you don't clean up this, there is a way to clean up this. Okay, so it's not cleaned automatically by itself. Okay, so there is a extra work you need to do to remove these dead tuples. Okay, and that work is done by this auto vacuum process. Okay, so auto vacuum you can configure. Okay, there are few configurations like percentage of dead tuples. Let's say 10% if you configure. So whenever 10% of rows are dead or dead tuples are there, then your auto vacuum process will be initiated, and then it will clean up, okay, those dead tuples. Okay, so then it gets the space, and whatever the new row it comes, so it occupies that space. Okay, so this is a very major concern of the performance of the database. Okay, so auto vacuum, because if you have a lot of dead tuples in your tables, okay, so there is a huge IO which needs to be done on the file, unnecessary IO. Okay, you have dead tuples and it's still scanning the dead tuples. Okay, so that's why maybe I'm not sure, maybe you have already done that. Okay, so this is a regular process in Postgres database. Okay, there are two vacuums. Again, auto vacuum. In auto vacuum, so it just makes the space wherever the dead tuples are there, it will clean up and it will just make a space in that. Okay, and you can run this manually also. It's auto vacuum is nothing but based on your configuration, it runs automatically. Okay, so that process will be initiated and that will just clean up the data tables. And you can run manually also whenever you want. Okay, so probably that needs some elevated privileges. Okay, super user. Okay, so that you can run manually also, auto vacuum. Okay, and there is two types of vacuum process actually. Okay, normal vacuum process and full vacuum. Okay, normal vacuum, what I told, okay, that's what it does. So wherever the dead tuples are there, it just clean up the dead tuples and it just make room for the new rows which can come and sit there. When it comes to the full vacuum, so full vacuum is something, it recreates a table again. Okay, I can say, or when you do a full vacuum, you can reclaim the space. Okay, so let's say you have 10 pages occupied by your table. Okay, 10 pages, 8 into 10, 8 KB, 80 KB is occupied by your table. Out of that, maybe each block or each page has some space in that after auto vacuum. Maybe dead tuples are created in maybe 4 or 5 blocks, probably. Okay, and you have run the auto vacuum or normal manually, you have run the vacuum, so with which that space is created. Okay, that free space is created, and that free space you can use for the insert. But let's say there is no insert or no data comes in my table. Okay. When you run the full vacuum, so what happens is that, let's say 4 blocks are completely blank out of 10 blocks. So it will make 6 blocks when you run the vacuum full. You can reclaim the 4 block space. So that is called as full vacuum. And when you run the full vacuum, exclusive locks will happen on the tables. So always, so that's why we usually not run full vacuum, okay, because full vacuum needs the downtime. So whenever you run the full vacuum, just make sure that no transaction are happening on that specific tables or indexes. Okay. So that's one thing you need to, otherwise, okay, you may face issues. But normal vacuum, there won't be any exclusive locking on the tables. Okay. So same time you can run some transactions, and same time you can run the vacuum. So there won't be any problem with that. But full vacuum, yeah, it's a, you need to in the downtime only. So that's what about the vacuum. Okay. And stats collector. Okay. So, the stats collector is responsible for collecting the stats. Okay. So just like any other database. Okay. So you have the process of collecting the statistics on the table level, index level. Okay. So for your optimizer to choose the best plans. Okay. So that's about the stats collector. Okay. And error log files. I think I discussed already all error log files. So these are the 6 background process, main background process. Okay, so and when it comes to the replication, so let's say you want to configure a streaming replication in Postgres. So maybe you can see one more process called wall sender. Okay, so which is responsible for sending the walls to the other cluster. Okay, so where you have the standby database. Okay. So, but that's not a default one. Okay, so when you configure only the replication, that will be started. So next is process array, so which maintains the information of all the processes of the Postgres. Okay, so the main thing here is shade buffers, wall buffers, and there are other memory components also, maybe like work memory. Okay, and there will be maintenance work mem. Okay, so just like shade buffers is a shared memory, right? Means all the servers can share the data which is present in the shared buffers, but on top of that, you have the private memory also, right? Every session will have its own private memory. Okay, so you take Oracle, I think maybe in SQL Server also. So in Oracle, we call it as PGA. Okay, so in Postgres, we call that as a work mem. Okay, so every session which connects to the database, okay, they have their own memory, and we can define that through a parameter. Okay, or we call that as a work memory or work mem shortcut. Okay, so this work mem you can define, and this is responsible for like whenever you initiate any variables, or whenever you do joins, or whenever you do any sorting. So for these kind of things, this work mem will be used. Okay, so this is the basic configuration, okay, or basic the architecture of the Postgres. So let's compare with Oracle and Postgres. Okay, so see, when you start the Postgres, so Postmaster is the main process. Okay, so which will be started first, and yeah, so this is the main process which is responsible for receiving the incoming request, just like listener. Okay, so if you take a listener, listener is the first process which receives the incoming request, right? And then the listener will hand over to the server process. So here, Postmaster process is only one process which receives the request, and it will spawn one more process for each connection. Okay, so that we call as a Postgres server process. Okay, so that is the responsible of the Postmaster process. But there is a difference, a small difference between this Postmaster process and the listener process. So if you take the listener process is independent of the database. Okay, means you can have your database running without the listener process up and running, right? Probably the remote connections you may not get when the listener is not on. But the local connections means the connections which you make from the same server, that can work, right? But when it comes to the Postmaster, this process is not independent of the Postgres server. Okay, it means a database cannot be up and running without the Postmaster process. if you kill the postmaster process, okay, complete cluster will come down. Okay. So that's the main, you can say that is the first process of Postgres. And from that, the remaining all process will be spawned. But whereas in Oracle, if you kill the listener process, whatever the connections that are already established, that process will not be affected. Only it affects the new incoming requests, right? So it won't play a role in sending the data reverse. Okay, it only plays the role in taking the connection, and it's independent also. If it breaks, there is no connection between the listener and database. It's just a registration, that's it. But if you kill a listener, nothing will happen to the database. Okay, database will still be up and running, but it's not the similar case in Postgres. If you kill the postmaster process, that's it. Your complete cluster will come down. All connections will be gone. Okay. So that clarified, right? So this is how, okay, so we already discussed this. Okay, so this is what I told. Okay, so postmaster sticks, it spawns one more process. Okay, so and each process you have the work mem, and then each process can use the shared memory. Okay, I think this is like so parsing phase, optimizing phase, and executing phase. This is how the statement will go through. So you can see here. Okay, so when you start the Postgres, okay, so postmaster process is the first process. Okay, it will be started. Okay, so and postmaster process is one of the most important process. Okay, so that's all you know. Okay, so postmaster also works as the Postgres. So basically, okay, I told like all other process will be spawned from the postmaster process, and also it is also responsible for taking the incoming requests. So physical database structure. Okay, so basically we see the terminology in Postgres we use as cluster. Okay, so it's not same thing like cluster. Most of the people think that cluster is something used for high availability. Okay, but in Postgres terminology, okay, so cluster, when I say Postgres cluster, don't think that it is something like shared concept where we can use that for high availability. So it's not that. Cluster is nothing but it's a collection of databases. Okay, so I think if you know in Oracle, maybe SQL Server is you can relate the SQL Server with PostgreSQL. Probably not the Oracle until means 11G version. Probably from 12C with multi-tenant architecture. Probably you can relate the Oracle to Postgres, but when it comes to the SQL Server, I think you have one instance and multiple databases, right, in SQL Server also. Okay, means one set of memory components. Okay, one set of background process, which will be working on multiple databases. So here Postgres is also similar that. Okay, so you have a whatever the background process and memory we have discussed so far. Okay, so this is something like one set of components. Okay, background process, memory with multiple databases. Okay, so that's what is a cluster. Okay, so each cluster has a separate data directory, port, and processes. And a cluster can contain multiple databases. Okay, so basically when you initiate a cluster, okay, when you create a cluster, okay, I don't know like about the SQL Server, but when it comes to the Oracle, okay, so installation phase is there and database creation is there. Okay, in Postgres, so there are two phases actually. One is initializing the cluster. Okay, second part is creating the databases. It means whenever you initiate the cluster, okay, so if you take any database, Oracle database, okay, I think few people already know about Oracle. Okay, I'm not familiar with SQL Server. So if you take a Oracle database, okay, think about the not means normal architecture, not the multi-tenant architecture, non-multi-tenant architecture. Okay, in that means till 11G, when you create a database, okay, then only you will get like parameter files, you will get control files, you will get database files, all those things you'll get. Okay, the database is created and each database will have its own parameter. But here, when you create a cluster, there will be an instance created and there will be few databases created automatically. I think in SQL Server, I don't know, like MSDB is the database, master database, something will be created, right? Okay, in SQL Server. Okay, so it's you may call that as a master database, something like that. So in Postgres also, when you initiate a cluster, it creates few databases, or mainly it depends. Like
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
if you use the open source, it creates a database with the name Postgres. Okay, if you use the enterprise version, EDB version, it creates like two databases, one with the EDB and one with the Postgres, and two other templates it creates. Okay, so on top of that, it just doesn't create the database. Okay, on top of that, it creates few files required for your cluster. So that is basically, we call that as a means you have to choose the directory. Okay, let's say I want to initiate the cluster. So whenever I'm initiating the cluster, so you need to specify the directory for that particular cluster. Okay, and that directory we call as data directory. In that directory, it will create all the required configuration files, okay, authentication files, and the directory for your database files, the directory for your wall logs, the directory. So these few default directories it will create in the data directory. So that you need to mention, okay, where you want to, what you want to choose, which data directory you want, okay, that you need to choose. Okay, so yeah, so here you see, okay, so default installation directory location. Okay, so you can choose. Okay, so this is basically the software installation. Okay, so installation directory. Okay, so you have bin directory, you can choose data directory. This is basically the EDB version. Okay, so you won't get EDB plus with normal Postgres. Okay, so but remaining all things you will get. Okay, so this is the, you can have that installation directory. Okay, and this is the data directory. Okay, cluster data directory layout. Okay, so when you initiate the cluster, okay, so this is basically when you install the software, you will get this. Okay, but after installation, you need to initiate the cluster. Okay, so when you initiate the cluster, okay, so these are the different directories, okay, which Postgres creates. Okay, and in this, mainly you can see base directory. So this is the directory where actually whatever the files that are related to databases. Okay, so let's say you create a database, okay, a new database or in any existing database in the OS side. So this is the directory where actually all of your files will be created. Okay, and you can create the table spaces also in Postgres. Okay, so when you create a table space, so there will be a symbolic link created from that directory to that new location. Okay, and pg underscore xlog. So whatever we discuss, the wall segments. Okay, so write ahead logs. So that all will be generated in this pg xlog directory. I think maybe in the newer versions, probably maybe 13 or 14, so they changed the pg xlog to pg wall, I think. Okay, so but the content is same, so you will see the uh, what is the wall segments in that directory. And pg log. Okay, so whatever the database related log files are there, okay, those all files will be created in the pg log. Okay, so there are few things here. Okay, so like pg snapshots, if you use any snapshots. Okay, and pg statistics, so this will discuss maybe further. And coming to here, postgresql.conf. So this is the main configuration file for the Postgres database. Okay, so where all of the configuration parameters for your Postgres database will exist, and you can change those the after once you create the cluster. Okay, so maybe later you have a different methods of changing that parameter values. Okay, and next is PGHBA conf. Okay, so PGHBA conf, we call that as a host based authentication. Okay, Postgres is host based authentication. So whatever the authentication means, the connections you want to allow from the different users, so that you need to place in this pghpa dot configuration file. Okay, so basically it will take like the host name or IP address from where the users are connecting. Okay, and to which databases the users want to connect, and what is that? The kind of authentication. It has different kind of authentications. You want to provide a password or a trust authentication or SSL certificate. So there are different types of authentications. Okay, so that's the main file for the authentication. So it's not like, remember, I don't know about SQL Server again. Oracle is not a host-based authentication, right? Means there is no such thing in Oracle where you have to put the IP address or host name of the client in the database servers, right? So you just create the database and share the host name or IP address or port where they can use the TNS names or they can use the Easy Connect. Okay, so they can connect to the database, and you don't need to explicitly add the IP address in any kind of file in Oracle database. Yeah, so but in few cases you can do a kind of firewall using SQLnet.org, I think. Okay, so you can just add few IPs if you don't want that to be connected, but there is no exclusively or explicitly to mention the IP address to connect to the database in Oracle, but it's in Postgres. This is must. Okay, if someone wants to connect to the database, you need to add their IP. Or if you give 0.0.0.0, then you are open to everyone. Okay, everyone can connect to the database, but we usually don't give such kind of range. Okay, like 0.0.0.0, or you give something like range at least. Let's say your clients are in some specific network. Let's say the 10.10.10. Okay, so all the machines which are there in the 10.10.10 network can connect to the database. Okay, so the range you can give. Okay, and or a specific IP you can give, or if you want to open wider range to all users, just give 0.0.0.0. That's it. But we don't use that. Okay, that's what. Okay, so pgident.conf is also used for the connections, but that is mainly for local connections where no need to specify the password less authentication, that you can use pgident.conf. So next is postmaster id. Okay, so postmaster id is PID, process id. So whenever you initiate or start the cluster, okay, there will be a process associated with the postmaster, and that process id will be captured in this file. Okay, so that's what. Okay, so the main things. Okay, so where this is the main thing. Okay, whenever you are choosing the data directory, remember, make sure you have the enough free space, okay, for your databases. And one more very important thing compared to Oracle here. Okay, so in Oracle, I don't know whether you guys know the administration part or not. In Oracle also we have the database files, right? So maybe as a developers, maybe you might have faced the issue like running out of space, unable to extend your table space, 128 bytes or something like that. So whenever you request your admins, maybe they add files. Okay, but what happens exactly in Oracle means you add a data file first only. Means what is meant by that means, let's say I have 100 gigs of space on my OS. Okay, I'll create a data file with 50 gigs. Okay, it means I'm just reserving from 100 GB, I reserve 50 GB as a database file. Initially, it will be free and I allocate to someone, then they start pushing the data into that. So it means you are reserving the space from the OS initially only in the form of data file, and then you will start using that. But in Postgres, there is no such thing like creating the data file. Okay, you just create the database. Okay, and there is no such reserving the space to the database initial phase only, or it won't reserve, I can say. You just give the directory, that's it. Whatever the space that exists, when you create the table, then it will create a file. Okay, and always remember, every table will be created as a file in the OS level. Let's say I created 10 tables. So 10 tables means you'll have 10 files in this data directory. Okay. So each file, okay, so that's again the index part. I don't want to get into that depth. Okay. So that's the difference mainly in Oracle and Postgres. So the here you don't, there is no such kind of reserving the space and then you put the data. Here you put the data, then it occupies the space. There you occupy the space, then you put the data. So that's how it works. Okay, here you can see a file per table and file per index. So each time you create a table, a file is created, and even for the index, okay, table space is a directory. Okay, in Oracle, a table space is group of data files. Each database that uses that table space gets a subdirectory. Okay, so again, directory in subdirectory like that it will go. So each relation using the table space or database combination gets one or more files in 1 GB chunks. So each relation, so relation is nothing but a table or it can be an index. Okay. So, and the file will be of 1 GB chunk. Okay. Means once the file crosses 1 GB, it creates one more file. Okay. So each file size maximum will be 1 GB. And once that reaches to 1 GB, it creates one more chunk and it waits till it reaches to 1 GB. And if it reaches to 1 GB, again, it will create one more file. Like that, it will keep on creating these files. And each file will have a naming called file node, okay, or rel file node. It's number, okay. That number will be associated with all these chunks, okay. So, and we have free space visibility map. That's not part of this, okay. So this is how it will be, the layout, okay, the Postgres database layout. You see here, data directory, you have the base directory in this. Here for each database, let's say I create a database like A, B, C, D, like that. For each database, a number will be given, that is OID, object identifier, okay. So there will be a directory created with each database OID. And under that, you will have a subdirectories again. Means this is a subdirectory in this. And in this directory, you will have the actual data files. So like this, it will give the number. So for each table, I told it create a file. And each table also will have, every object in Postgres will have the identifier. And that identifier will be associated with this data file. So this is how it works. And when you create a table space, okay, so a directory will be created, means under this pg underscore table space directory, and you point, let's say you create a table space using this directory. So this is a symbolic link which points to this actual directory, and again in this the same process. Okay, so basically when you create a database, this is what you need to consider, right? Okay, so whether you have the enough space in the data directory. So you need to make sure that you have the enough free space, and you can create a table space like, let's say you have a multiple databases, multiple modules or multiple applications or multiple clients. Maybe you can create separate table spaces for each database, and you can go on like that. Okay, means what I can say is you can have the data directory one and the actual database in the other directory. So that's how you can also maintain. Okay, so this is the page structure, how it looks. Okay, so you have the page header and you have the tuples, you have the free space. So it's, I told like page is something like your block size in Oracle. So in Oracle also the default is 8K. So here also you have 8K and you have header and tuples. So this is how the page structure will be like. And this is something like page header, general information about the page, row pointers, and the actual row will be here, and which row points to this room, and you have free space, unallocated space, new pointers allocated from the front, row index. This is, I don't think this is much in-depth thing. Okay, So this is a basic architecture, okay, basic layout, okay, I can say, okay, in Postgres. So main thing is, yeah, initiating the cluster and deciding the data directory. And obviously you need to have, okay, the permissions as a Postgres user. So wherever you are initiating the cluster or wherever you are choosing the base database directory, so there you can choose the permissions as a Postgres and make sure the space is there. So that's what the initial layout. Okay, so here, so if you see, while initiating the cluster, so this is the data directory I have chosen. Okay, so and when we start the Postgres, so you can choose that, means you have to give that data directory because you can have multiple clusters. Okay, you can on one machine you can create multiple clusters, but you need to have the different data directories and different. Okay, so let's go into this directory. So you see here, okay, so this is the data directory for my database. Okay, so this is the main cd base. Okay, so you can see here we have different directories again inside. So this directory one is a Postgres database, and remaining are the directories for each database. Okay, so like that. Okay, so you have Postgres SQL conf. Okay, so I'll show this. Okay, so let us complete this. So if you go into this directories again, okay, so you see here, okay, so this is how the files, whenever you create tables, okay, so it will create files like this. Okay, every file will have like file node number. Okay, so here for every table you create in the database, okay, so the file will be created under that respective directory. Okay, so if you see here, so here 14.14171.24576, these are all the database identifiers I told you, right? Object identifier, database object identifier. So whenever you create a new database in the database, so there will be a object identifier, okay, allocated for that particular object, that is database. With that same number, a directory will be created here in the data directory. And once you connect to the database and create any objects in that database, so that particular, for that particular tables, okay, so you'll have, okay, the files created under that corresponding directory. So like this. So VM is like a virtual map, FSM, free space map. So that is something related to the DBA specifically, I can say. Okay, so this is about the data directory. Okay, so if you go back, okay, so this is data directory. Yeah, so Postgres SQL conf. So this is the main configuration file for your cluster, for the entire cluster. Okay, so you see here, okay, so this here you have a lot of parameters. Okay, so PGHBA data directory identifier. So almost everything I have. This is the max connections. Okay, so this is basically uh, two things are important, like which port you want to use your cluster. So default will be 5432. Okay, the default port. If you want to change, you can change here. Just uncomment that. I don't know, like in, say, in Windows, also you will see this configuration file. So if you don't want the, uh, I mean, that port, you can change the port here, and you have to restart the cluster again. Okay, and if you have two clusters, okay, let's say I want to create a one more cluster. So two things you need to make sure when you are having multiple cluster on one server. Each cluster should have a unique port. Means, let's say I created a cluster now with 5432 port. If I want to create a new cluster, I cannot use the same port again. If you use, either you can start only one cluster itself. You cannot start two clusters simultaneously. So the port should be unique, and also the data directory should be separate. Okay, you cannot choose the same data directory, because if you choose the same data directory for the other cluster also, so it will override the existing the cluster data directory. So choose the data directory and port separately. It should be unique for each. cluster. And if you see here, they give some comment here. So some parameters you can change dynamically without the restart of the cluster, but some parameters you need a restart. So here it specifies like whether you need a restart for the for this parameter to come into effect. Okay, whether you need to restart the cluster or not. Okay, so it means these are all requires restart, means you need to restart your cluster completely. And max connection, so this is something like you need to choose like how many simultaneous connections you may expect to the cluster. Okay, so that you can give. Default is 100 itself, so if you want to increase, you can increase that. Okay. Next is so yeah, so there are like authentications. Here you see shared buffers. Okay, so you have the how much shared buffers you want. Okay, so you can give that. A minimum is 128 KB. Okay, so 128 MB we have given. Okay, so that you can change. And here I was talking about the work mem, right? So this is a work mem 4 MB. I have that is the default. Okay, so I think minimum 64 KB you need to have. Okay, so you cannot have less than this for these parameters. Okay, so you can choose maintenance work mem. Okay, so you have maintenance work mem is something like any maintenance activities you do. So that work mem that is separate memory for that, and auto vacuum work mem. So you say -1 to use maintenance work mem. So it uses this disk work mem only, automate maintenance work. So there are a lot of configuration parameters you should go through. So wall level, okay. So this is basically uh, decide, okay, what kind of wall level you want. So when you want to go for minimal means, okay, it will generate the minimal wall data. Means you cannot configure the replication when you go for the minimal wall level. So if you want to go with the replication, let's say streaming replication, building the physical standby database, then you have to change this wall levels to the replica, or if it is a logical standby, so you can go with the logical option. And this is archive mode. So this is already I have put on. Okay, so if you want to enable archiving on your cluster, okay, so this is the archive command, sorry, archive mode, and below this is the archive command. So here you can decide, okay, you can use your OS command. So I'm using Unix, so I'm using the CP command. Okay, so to copy the files into this is my archive location. Okay, so you can choose any directory here. And one more thing is you can even choose the remote location also. Okay, so not only the local machine, let's say I want to push my archives into some other machine, let's say. So you can choose that remote machine also, so that it will copy all of your archives. Okay, so sorry, it will generate all the archives on the remote machine. So this is the authentication file. Basically here you put like which users from which IPs. So this is how you can use like type, database, user, address, method. Okay, type is host. Okay, and database, to which database that user needs to connect, and what is the username, and what is the address, the IP address of that particular machine. And method, trust means no password. MD5 you have other methods, so where you need to provide the password for that. So this is the main authentication file. So in the PostgreSQL conf, that is not the authentication file. Okay, so here let's say I want to allow some IP address. So there is a host and database, to which database you want to connect. If I give all, so you can connect to all databases. And user, so with which user I need to allow. Maybe you can, if I give all, so you can use any user to connect any database from whatever the IP address I mentioned here, from that IP address. So you can connect any user with any user to any database. Or I can mention here a specific database name and a specific user. So from that IP, you can use only that specific user to connect to that specific database. That's it. Okay. So here, this is a local. Okay, 127. This is in Unix, so you have the local IP 127.0.0.1. So this is the IP. Okay. So let's say I want to add the range. Okay. Let's say 10.10.10.0 / 24. So 24 represents that subnet on it. It's not particularly IP. If you are, I think maybe you're aware of that IP configurations. Okay. So you can allow a specific machine or the complete network. Let's say maybe your company has a specific IP network. So I can use that up till that subnet, and I can give 0 and I'll give 24 here, so that whatever the network range is there in this, so all users can connect with whatever the information I provide, whether with the all users or a specific user or all database or specific database. So I can mention everything. And whenever you change anything, like let's say you add any new entry or remove any new entry, okay, so you need to restart, reload, not restart. Okay. Mm, I came back, I think. pgctl reload. Okay, simple command. Okay, I'm in different directory. I need to go back again to the bin directory. So you see here, so this is my wall directory. So I think from 13 they changed. So I think previously up till 12 version, maybe instead of PG wall, maybe you can see PG xlog kind of thing. Okay. So here, this is how the wall logs looks like. Okay. So these are all the wall log files. Okay. So, and if you see the archive status, okay. So this is like, it says done. Okay. So let's say if it is still archiving. Okay. So here, when it says on February 17th, the last archive is done. Okay. Since then, I did not make any changes on my database. So that's why we did not have any much uh, archiving happen. So whenever the archive happens, so you can check the archive status here in this. Okay. So this is the wall segments, and each wall segment you see here, 16 MB. That is the default size of each wall segment. Okay, 16 MB is the default size. Okay, so that is about the walls. And coming to the max parallel workers. Okay, so this is for maintenance. Okay, this you can, okay, go max worker processes, those are 8. Okay, so this you can change. Okay, this will reflect the maximum parallelism, I think. No, this one, max parallel workers, not max worker process. Okay, so maximum number of that can be used in parallel operations. Okay, so that is 8 parallel threads you can use here. Okay, so this is how I connect to my database using PSQL client also. Okay, so, and you see here there is a Postgres database and some templates and tests. Okay, so this is using a PSQL I can connect. Okay, so, and here there are a lot of, okay, using PSQL. Okay, so you have these kind of things where you can see the list of databases. Okay, the list of users. Okay, the list of table spaces. Okay, so PG default, PG global. So these anyhow will come by default, these 2 table spaces. Okay, and yeah, so they were like, let's say I want to see schemas. Okay, so I want to see to which database I currently connected. Okay, so I connected by default to the Postgres database. Okay, so if I want to switch from this database to any other database, I can just give /c and the database name, so I can connect to the database. So this is from the PSQL. So if you have, so with the Postgres installation, you get PSQL client by default. Okay, just like in Oracle, if you install Oracle database server, you will get SQL plus client by default, right? Same like that. With the Postgres, you have the PSQL client by default. Okay, so you can use that client to access your database. Okay, so next, so you can list out the PSQL. So this kind of things maybe you cannot run from the PG admin. Okay, so this is only we can run from the PSQL. So do you have I'm not sure, like I see PG admin has the feature, maybe it's a new feature, beta feature. So you can initiate PSQL client from PG admin also. So then you can see the schemas here. Okay, so I have a schema. So I think you know this concept. I think maybe you're already tried. So you have a schema, and the default schema in Postgres is the public schema. Okay, so, and you can create your own schema. Okay, so and by default, so
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
so you see the search path. So this is what it defines. Okay, basically, okay, the default search path. Default search path in the sense, like you see here, $user and public. You have two things for the search path. It means, let's say you have connected, okay, with some user A. Let's say user A is there. You connected with that user, and you connected. You created a schema with A. Okay, same name as a same schema name, same as the username. Remember. So here, okay. So I don't know, like if everyone is from SQL Server, it is fine. But if anyone is from Oracle, in Oracle we don't have the concept of user and schema are both same. I can say in Oracle. So there is no like separation of user and schema there. Okay. So but in Postgres, okay, user is different and schema is different. Okay, you can have multiple schemas, and you need to connect to the schema basically, or not connect to schema. I can say you need to create a schema, and you need to define, or you need to select in which schema you want to create the objects. Okay, so here by default, when you connect with a user, let's say I took an example, like I connected with the user A and I have the schema A. Then if I create tables, by default, it will go in the A schema. Otherwise, if it can't find that schema with the same username, then it will go to the public schema. So that's how it works. You got my point? I mean, like if you don't, it's not required. What I'm saying is, if you create any object, okay. So here I have EMP and public, two schemas. Okay. So and I connected as a Postgres user here, right? That to this database as a Postgres user, and in this database you have EMP and public. So if I create table, okay, let's say create table A. Okay, table created. Okay, so let's see the tables in this. Okay, so here you see this is to show like to list out the tables. So you see where it went actually by default, it went to the public schema, right? Okay, so because there is no such schema with the user Postgres. So what you can try is, okay, probably you can create a schema same as a username. So that's how, okay, so it works. So database cluster, so we have defined, so what is a cluster? Okay, so we have when you create a database cluster, so we have like 3 databases. Okay, so in that 2 are templates, template 0 and template 1, and one is the default database Postgres. And whenever you are initiating the cluster, okay, so you have to specify the data directory. Okay, so this is the command. Okay, so initdb. So once you install your Postgres software, so you get all these binaries. Okay, so in that, okay, initdb is one of the utility. Okay, so with which you can create the cluster. So this is the first part of creating the cluster, and only thing here you require is you need to mention the data directory. So that we already discussed yesterday. Okay, so and this ownership, so the ownership is very important. So since we install the Postgres as Postgres user, so with whatever the user. Okay, so you are installing, so better you have the permission of that directory on that user itself. Okay, so these are the different options. Okay, so with which you can create the cluster or initiate the cluster. Okay, so init db and options. So here all the different options. Okay, and the main options here you need to use is this one. Okay, so database or data directory, you can say. Okay, so and remaining, okay, so these are optional, so you can mention who is the super user for your cluster. If you want the password to be prompted, you can use this option. Xlog directory is for transaction logs, which we discussed. Okay, so the main options, okay, is this one. Okay, so if you see here, okay, so this is basically the enterprise db, but normal postgres also will be the same option. So let me show the practical one in this. So you can see here in the Postgres, okay, bin directory, wherever you install your Postgres. Okay, so you have this utility called initdb. Okay, so with this utility, okay, you can initiate the cluster. So I have already initiated the cluster. So you can create you can create multiple clusters. Okay, so let me see whether my cluster is running or not. Okay, so you see here, okay, so my database is already running. So one cluster is already up and running. So yesterday we discussed about one of the process called Postmaster process, right? So that is the main process for all the Postgres processes. Okay, so here you can see this is the Postmaster process. Okay, the first process which will be started is the Postmaster process, and that is the main process. Here you see the Postmaster process ID is 1, and the child process is this 20286, and then 20. So this is the parent. This is the parent process ID. This is the process ID. And if you see here, all of the processes, this process ID, the parent process is this one only. Okay, so if you connect to the Postgres database, okay, so I told like for every connection which connects to the database, it spawns one new process. Okay, so let's say I'll connect to my one of the database now. So yeah, so you can see here, once I connected one connection, so you can see there is one connection from the pSQL to the cluster. See the difference between this output. Okay, so here this is the output we got. Okay, and here if you see, once the connection is established, you can see there is one process created. Okay, so this is the process created for my connection. So like that, for every connection which happens to the database, a process will be created, and you can see from this process list. And here you see this is the local. Okay, so I connected from the local machine. So let's say you connect from the remote machines. So instead of local, here you will get the IP address of the machine from which you connected. Okay, so this is how you can list the number of connections also on the cluster, okay, from the OS level also. Okay, so and once you disconnect, this process will be gone. Okay, so let's say if I want to initiate a new cluster. Okay, so the first thing is, let me check my space. Okay, so now let's create one cluster. Okay, so you can just give initdb -- help. Okay, so you can see what all the options, yeah, so you can use for initiating the cluster. Okay, so I created a new directory in the DB backup, that is PG data 1. So remember, okay, I told yesterday also, when you are having the multiple clusters, so just make sure that data directory is unique for each cluster. Okay, so now let's say in DB, okay, so and you can give -d. Okay, so this is the cluster. Okay, and you can specify the username, database super username, and database password. Okay, so -b db backup pg data 1 -u make postgres. So enter new super user password. So I'll give password as Postgres itself. Postgres. Okay, so think there, that's fine. Okay, so now my cluster is created. Okay, so the data directory I have used is pg data 1. Okay, so here, if you go to this PG data, this directory, so whatever the directories I shown yesterday, so the same kind of directories you can see in this also. Okay, so yeah, so you see, okay, so same kind of files. Okay, these are the default files which you get. And here, one important thing before starting the cluster. So the cluster is not started yet. Okay, so the new cluster. So if you see the process list, okay, so you can see this cluster is started. Okay, so the cluster which I have created now, that cluster is pointing to the different data directory, that is db backup pg data 1. Okay, so here you, okay, so you started the cluster already. So how we can start the cluster? Okay, so we can start the cluster with the pg_ctl command. But before that, one change you have to do before starting the cluster. What is that change means? Port number. Okay, so if you see the port number of this cluster, okay, so this cluster is using the default port, means when I initiated the cluster, I haven't changed the port number. So by default, 5432 will be the port number for the Postgres. Okay, so and that where you can see in the PostgreSQL configuration file. Okay, so if you go here for this cluster, okay, yeah, so port is 5432. So by default, it's using the same port. So if you try to use the same port for the other cluster also, it will not come up. So the port number should also be unique, just like the data directory. So if I try to start the cluster, let's try and see. So you may get the error. Okay, so this is for checking. Okay, pgctl command, pg_ctl is the command. Okay, so with which you can start the cluster, stop the cluster, and check the status of the cluster. So when you are giving the status, so it's better always give the data directory location. So you can see here, okay, server is running, and you see the process ID also here. So just now we have seen this is the main process ID for the Postmaster process. So here it shows what is the process ID of your Postmaster process. Okay, so now let us try to start the cluster which we have created now. So we use the data directory as pg data 1, not status. We can check the status once. So it says no server running with this data directory. Okay, so let me start this pgctl start. Okay, so here you can see what it is saying is could not start server, examine the log output. So it could not start the server. So yesterday, I think we have not discussed, I think I haven't shown the database logs. So in the data directory, you will have the database logs. So if you go to this database directory here, okay, go to this directory, there is a directory called log. Okay, so you can see here, this is my database log. So open this database log. Okay, so you can see here what error exactly it is. Could not bind IPv6 address already in use. Hint is another postmaster already running on port 5432. If not, wait a few seconds and retry. So basically what it is saying is it's just giving the hint also, saying that if there is any Postgres process, okay, or cluster using that 5432 is already running. So, and we can see this is already running. So what we have to do here, so we have to change the port number for this cluster, and then we have to start. So let's try that. So let's change it to 5434. Okay, and change requires restart. Okay, so even when you change this value when your server is running, so you have to restart the complete server. Okay, so for this new value. Okay, so I changed my port now. Okay, so let me save this file. Port is 5434. Okay, so let's restart it again. So you see now the server has started. Okay, so now you see, so we have two clusters running. So one is the cluster just now which we have created using the data directory db backup pg data 1, and the other cluster which was already running before, so using the this data directory. Okay, so like this. So whenever you initiate a cluster, so this port is also very important. So data directory comes into the picture while creating the cluster itself. Okay, that needs to be unique. If you give the same data directory which is already part, it may overlap. So just be careful on that. And the port also. So if that is already being used by any Postmaster, so before starting itself, try to change. And if, because some companies may not use the default port, okay, so they may use some different port. So in that case, so before starting the cluster, so you can change the port number, okay, in that configuration file and can restart. And this one, okay, even later also you can change. It's not like initially if you put 5432 and later you cannot change. It's not like that. So if you want, you can change later also the port number. Okay, only thing is restart is right. So now we have two clusters here, right? So I have a PL SQL client. We can use that to connect to the cluster. So what cluster I need to connect? So previously I had only one cluster. Okay, so I have used, so you see here, okay, dot /p SQL. Okay, I connected to the cluster. Okay, so but to which cluster I have connected basically? Okay, so I have two clusters here. So before connecting the cluster, okay, so you need to specify the data directory actually. Okay, so dot .psql hyphen capital D. Okay. Okay, I think you need to mention, you can mention the port. Let's use the port hyphen P5434. Okay, so you can use this port. Okay, so to connect to the particular cluster. Okay, so now I connected to the new cluster. Okay, so otherwise, if you see, if without using that, still I was able to connect. So what exactly that, to which cluster it is basically getting connected? So we have a few variables here. Okay, so it's connecting by default port. Okay, so let's say I want to connect to the other cluster without using the port probably. So what I can do here, you see there is one environment variable called PG data. So you say PG data, it's pointing to something varly PG SQL, something like that. So what I'll do here is I will change this. Okay, so you see, is it connecting to PG data one? So it's not connecting to PG data one, it's still connecting to PG data cluster only. So this is not working. So what I can do here is I can queue PG port also. 5434. So you see the difference here. Okay, so here I just give pSQL. Okay, and see the difference between this output and this output. So here we have test and test underscore pg2 databases, and here we don't have the databases. So I connected to the different cluster. So here this is the environment variable I defined before connecting to the cluster. So there are some default variables. Okay, so system defined variables. So you can set that variable values and see while I am connecting. So I haven't used the port number here. Okay, so it is taking this variable PG port. So whatever the value that is there, okay, 5434. So previously there was no value for this variable, right? It was an empty. Okay, so then what it was doing is it was connecting to the default port, that is 5432. But now I changed the PG port value to 5434. Okay, so whatever the value that is there in the PG port, so that it will take while connecting to the pSQL. So basically, if you have any environment variables, okay, so you can set these variables in that whatever profile you have for your OS. Then once you connect to the system, so you can directly use, okay, just pSQL to connect to the cluster. So no need to specify all those options while connecting. So that is the easiest process. So if you have only one process, or if you have multiple clusters, so just This is the main thing which you have to mention. Okay. So yeah, so we created the cluster and we know how we check the process. Okay, so how we can shut down. Okay, so using the same pgctl command, you can stop the cluster also. Okay, you can do with the command prompt where your postgres binary is there. Okay, so from that, or you can set the path in your environment variable in windows. Okay, so from there also you can, if you set the environment variable, you can do any from anywhere, or else you need to go to that where the executables are there. So from there you have to run it. I think in windows you can start with the service also, right? From the service, if it is created in the service, so you can just start and stop the service. Just like Oracle also, when you install Oracle also, you have the service created, right? So you can just start the service, so the database will come up automatically. So like that, you can do that way also. Otherwise, this way also will be fine. Okay, so all this pgctl, initdb, so those all will be in your executables where your postgres binaries are there. So there you can find all of these commands. Okay, so yeah, so pgctl start options. Okay, so we have already discussed this. Okay, so psql. Okay, so you, while connecting to the database, yeah, so there are different methods. Okay, so edb psql, you won't get psql only. pgctl reload. Yeah, so what are the different options of pgctl? So one is we have used the status, one is you can start, one is you can use stop also. Okay, the other one is pgctl reload. Okay, so for few parameter changes, basically when we use this reload means whenever you change any parameters, some parameters requires the reload of the clusters. Reload is not something like a restart. Okay, just like if you are aware of Oracle, will reload the listener, right? lsnrctl reload to reflect the new configuration. Okay, so same thing, pgctl reload also, it will not restart, it will just reload the new configuration. So for few parameters, this reload is required. So you can just run pgctl reload. Especially this is required when you add a new entry or when you make any changes for your pghba config. Okay, so host based authentication, let's say I added a new IP address, okay, to my HBA file. So sometimes you may miss to reload, okay, but still the user may not connect to the cluster because that new value will not come into effect until you reload. So this is very important when it comes to the PGHBA conf. Okay, so this is two things. Okay, so you can either use the pgctl reload from the OS, or from the database you have the function pg reload configuration. So either you can use this or you can do. Okay, so pgctl stop. Okay, so there are three options you can use while stopping the database: smart, fast, and immediate. Okay, so you can say smart. Okay, so it just shutdowns only when all clients gets disconnected from your cluster. Okay, so fast is quit directly with proper shutdown. Okay, so it will disconnect and it will just means a graceful shutdown. So smart and fast. So and then immediate. So say we can say it's not a graceful shutdown. So it may need a recovery when you restart your cluster. Okay, so and you can use the options pgctl stop -m. Okay, I think -m is for smart. So, but usually we not regularly use. We can directly use like -m and options. F is for fast, S is for smart, and I is for immediate. I think. Okay, so you can use or normal pgctl stop. I think by default it will take fast method. Okay, so let's go through the object hierarchy. Okay, so once your cluster is ready, okay, so you can create the database. So how the object hierarchy will be there in the Postgres. So this is how, okay, so the object hierarchy is there. So the top level is your database cluster. Okay, so below that you have users and then databases and then table spaces. And then in the database, you have catalog schemas. By default, you will get. If you install any extensions, you'll get. And by default, you will have the schemas. Okay, public schema will be there by default. Or if you want to create your own schemas you can create. And under the schema, so we will get all of the objects. So this is, yeah. So maybe if someone is from Oracle, okay, you may get bit confused. So in Oracle, you see users comes under the database, right? But here in Postgres, users are at the same level of database. Okay, so like how I can compare means multi-tenant. In multi-tenant, you have common users and local users, right, in Oracle. So if you are aware of the multi-tenant architecture, so there are two types of users they have introduced. One is the common users and one is the local users. So if you take the common users exist in all PDBs. So you can think here the users in Postgres are like common users in Oracle. Okay. So, and it doesn't mean that again there is some difference between the common user there and here. Why? Because there in the common user, maybe that user exists on all PDBs, but still you need to have the specific permission on each pluggable database for that common user to execute something. So here also, when it comes in Postgres, so the users also you can create and you can give permissions on the databases which the users can access. Okay, and so all those things. Okay, so that's one thing. Means you can create users outside of the database. So that's one. Okay, so and PG underscore database. Okay, so these are few. You can get like what is the dat name. So these are the catalog views. So there are a lot of catalog views in Postgres. Okay, so you can get just by giving from PSQL, so /d capital S. So we'll list out all of the catalog views. Okay, so you can list out this list of schemas, list of relations, functions, and I shown you. Okay, so this is a database. I think you all know. So database you have just now we have seen schemas, and in the schemas you have database objects. So you can create. Yeah. So what are the different ways to create a database? Okay. So there are two commands. Okay. One command is you can create the database by connecting to the cluster. Okay. And obviously you need to be a super user, okay, for creating a new database. Okay. Or else you can create a database from the OS level also using the create DB utility. Okay. So here you can give like create database name, owner, enterprise DB, and revoke connect on database prod from public. So this is one of the thing. Okay. By default, when you create a database, okay, so the permissions. Okay, so there will be a public permissions on this database to connect. So what does that mean? So whatever the users are there in your cluster, that users will get permission to connect to this new database by default. Okay, so just for security purpose, if you don't want to give the access, or if you want to give access for a particular users only, so then you can revoke from the public and you can give the permissions to the specific users only. So these are the different options. You can specify the table space. Okay, you can specify the template encoding. So LC, we will discuss that what exactly is the LC. Okay, connection limit. Okay, so if you see, I think I have shown the configuration file. Okay, so parameters. Okay, so whatever we have seen from the PostgreSQL conf file. Okay, so you can check from the cluster also. So you see here the max connections for the complete cluster is 100. This is by default. Okay, so just now we have seen while creating the database, the connection limit means for each database, let's say I have overall on the cluster 100 connections. Okay, so I created two databases, let's say. So I want to limit the connections for each database, let's say. So for one database, I can give the connection limit as, let's say, 50. And from the other database, I can say 50. Means you can limit, or there are few parameters you can set at the database level also. So mainly the connections. So this is the important thing. Okay, max connections. When you create a new cluster, okay, so apart from the configuration of the memory, so the connections also will be taken into the consideration. So how many simultaneous connections you may expect to your cluster. So based on that, you have to change this value. Okay. So, and when you change this value, okay, so especially when you increase the value, decreasing, it's not a big deal, but when you are increasing the connections, so just make sure you have the good calculation of the memory, okay, on your server. Okay. So that is important thing. Okay. So can you see here PG tune? Okay. So you can use this. Okay. This is not like a hard limit which you can set, but at least it gives based on your configuration, like which version you are using. So here you can see we get different versions here in the drop down, like which version you are using. Okay. So OS type, so you can choose anything like Windows, what kind of application you are using for your database. Is it a OLTP or it's a warehouse application or desktop? Okay. And then how much total memory you have on your server. Let's say I have some 16 GB. Okay. And how many number of CPUs you have? Maybe I have 4 CPUs. Then this is optional. So what this basically you need to decide, because it all depends on how many connections your application may.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Initiate to your database. So this you can get some idea. Okay. So maybe like I will go for 200 connections. Okay. So, and SSD storage. So you can have like, if you are using the SAN storage, you are using the HDD. So what kind of storage you are using? Okay. So you can click on generate. Okay. So this gives like the some of the parameter values. Okay. The derived values means they have, like you can see here, shared buffers. Okay. So total memory is 16 GB I have provided. This is the memory of complete machine. Okay. The machine you have. Okay. So shared buffers, you can see this is 4 GB. So this is a calculation. So always remember this is 25%. Okay. So 25% of the RAM memory should be given to the shared buffers. Or else I can put in the other way, 75% of the memory you should leave for the OS. I can put in that way. Okay. So instead of 25%, okay, so you can take any other way. But shared buffers, the thumb rule is 25% of the total RAM. So that's what the Postgres community recommends. Okay, that's the value. That whatever the standard recommendations are there. So based on that recommendations, these values will be derived. Okay, if you see here, it says the shared buffers. Effective caches, we usually use this for mainly the query optimizing based on the index, maintenance work memory, and you see work mem. So these values will change. Okay, so let's say if I may take like 100 connections. So you see work mem has changed. So we have already discussed about the work mem, right? So work mem is something, the memory is which is private to each session which connects, just like the PGA in Oracle. Okay. So what all the things will be used for this mainly, so this is based on the minimal calculations again. Okay, so this work mem you cannot like decide like this work mem would be the optimal work mem for my database. Okay, so it all depends on what kind of queries you are sending onto your database. Okay, sometimes I see like we use huge joins. Okay, and workmem by default, maybe you can do KB, but you are joining like huge tables, maybe which are in GBs. So if you increase the workmem, so the query runs bit fast. If you decrease the workmem, the query goes slow. The reason behind that is if you have the more workmem, so what happens basically? when you join the statements, okay, mainly there are two types of joins, right? What is that? Nested loops and hash, right? So what exactly happens internally? Okay, it creates a hashing algorithm, or it creates data where it just keep on looping as per your nested loops, how it goes. So it loops, it checks all the data, right? So where that memory is coming from, that memory is coming from workman, right? And just like in if you take Oracle, okay, so like PGA, so you have in PGA also, what happens, the process uses more PGA when you push huge joins or huge sorting, right? Sometimes you may see these kind of issues. Okay, so mainly a DBS may face issues, and also as a developer, maybe you see some performance issue with the query. What happens if you have less work mem or less PGA? Any idea what happens if you have less? I can put in a general way. What happens if you have less less private memory for your session? So what could be the um, disadvantages, or what could be the performance issues you face when you have this less? Obviously it will go for performance lagging. So why the performance lags for when you have the less mem? So yeah, so basically what happens is, yeah, so you don't have the enough mem, so to calculate or to perform the complete task, it has to spill the data onto your disk, right? So obviously the disk IO will be slower than the memory. Okay, so you see when the memory is less, work mem especially, or PGA is less, if you have observed in Oracle, the temporary table space usage will grow. Why? Because the data which you are calculating could not fit completely in the buffer. It has to spill the data into the disk. And there in Oracle, you have a separate table space for that kind of activity. We call that as a temporary table space, right? So you see a rapid usage in the temporary table space when your PJ is less enough, or you are using huge data sorting or huge joins, right? So due to this spilling of the data into the disk, so the query performance will be slower. Okay, and obviously you may see this kind of issues mostly on the warehouse environments, may not be on the transaction processing systems, okay, because you may not work on huge data on the transaction processing, okay. But yeah, in warehouse systems, definitely you see these kind of things, and obviously you cannot give, okay, more memory also, okay, there also have some limits. So that's what in Oracle, same like how you have the temporary table space, we don't have any temporary table space in Postgres. Okay, so if you compare with Oracle and Postgres, you don't have undo table space and you don't have the temporary table space in Postgres. Okay, so but still it creates the temporary files. Okay, so it doesn't have a separate temporary table space defined, but it will still follow the same process what it follows in the Oracle. Okay, so if the data doesn't fit completely in the work mem, so it spills that intermediate result data into the disk. Okay, so it creates some temporary files, and once that query is done, so these temp files will be removed automatically. So that I'll show, okay, where it will be created. So that's the importance of work map. Okay, so min wall size, max wall size. So this is dependent on your transaction logs. Okay, so we have seen that, right? Okay, and this is about the parallel workers. Okay, so this is one of the means the standard, means the recommended configuration. Okay, which you can use. So these calculations are based on the Postgres community recommendations. Okay, so you can use this. Okay, so default random page cost. So this is basically, these are something related to your query performance. Okay, this is open source only. Okay, so previously this was used by second quadrant, actually second quadrant is acquired by EDB. So now they are not developing. So this is transferred to something new. So you can just use this link, pgtune link, and yeah. So what configuration, the base configuration you need to give, okay, here. Okay, so based on that, what parameters you can use for your database, so it can recommend. Here, add or modify the settings in PostgreSQL conf and restart the database. This is the recommended. There is one more thing here. You can see alter system. Okay, so you can change the parameters just like in Oracle. Okay, so you have the option of changing the parameters from the database right there. So instead of going to your parameter file and changing the parameters, so here also we have the same option of changing the parameters from the clusters instead of changing from the configuration file. So here, okay, so you can see alter system set, okay, whatever the values that recommended. So if you want to change, you can use these commands. So what happens when you do this alter system set commands? Okay, so basically, so if you see here, just like PostgreSQL conf, you have PostgreSQL autoconf. Okay, so what is that autoconf? Okay, so whenever you change the parameters using the alter system set commands, okay, so those commands will be recorded in this autoconf file. Okay, so if you see this file, so basically I haven't changed any parameters using the alter system. Okay, so let's try to change. We change for this cluster, PG data one cluster. So let's see the autoconf file. So here you see, so whenever you change the parameter using that alter system commands, so that will be stored in this autoconf file. Okay, and that this needs the restart. Okay, so just will restart. Okay, so pgctl restart. So you see here. Okay, so we have changed the parameter using the alter system command, and when you see the alter system command, so there is one thing you need to observe. Okay, so what is that? So if you see here, view Postgres. So here in the actual configuration file, you still see the 100 itself, but if you see the autoconf file, so there actually the changed value will be written. So if there are any values, if you change with alter system command, so those changes will be recorded in the PostgreSQL autoconf file. Okay, and whenever you restart or whenever you start your cluster, so Oracle reads these both files, and the whatever the values that are there in the autoconf, those values will be the actual one which will come into effect finally. And yeah, so when you migrate the databases, okay, so just be sure about your parameters on autoconf also. Okay, so just don't think that you have a parameters on PostgreSQL conf. So make sure that if you have any parameters specific, maybe you might have changed the parameters for your database or for your cluster using system alter system commands. So this cross-check autoconf. So if you miss that, probably you may end up with incorrect configuration for your database. So and always don't change make any changes in the PostgreSQL autoconf, any manual changes. Okay, it is always recommended. Don't touch using like OS commands, open that and change the values. Don't do that. Okay, for normal conf you can do, but for autoconf, it is always recommended by Postgres that you should not make any changes on the autoconf. So that is about the autoconf. So far, everything is fine, right? So you can use, yeah, so pgtune for like the standard recommendations. Okay, so and later we'll come through like mainly when we come across the different configurations like maintenance work effective cache size, okay, random page call. So these are mainly related to your performance related things. So yeah, so coming to the hierarchy again. Okay, we already saw the database, table space, users. They all exist on the same layer. Okay, so how you can see the database users? So /du, you can see what all the users existing in your cluster. Okay, so and if you see what all the table spaces you have, /db, and to list the databases you can use /l. Okay, so you can create a new databases, you can create a new users. Okay, so always. Okay, so how you can create a database? Normally you can just create database test. So you can see here. So you can see here, create database test. Database is created. So just give /l. So you can see the database is test. Okay. So if you want to get more information, if you give L plus, so it will also give the size of the database, and you can see what is the default table space of that particular database. Okay. So, and you have different two templates. So this will see further how you can create databases using the template. Okay. So we have just created the database test, and mainly the encoding it will take by default with the other templates UTF-8. This is the default and majorly use the encoding for the databases. Okay, so you can connect directly to the database using pSQL. Okay, so if you just give pSQL, okay, so how you can say like with which data to which database you connected. So you can just give select current underscore database. So Postgres. So or else see to exit. Okay, so I may not be telling this. So to exit actually. Okay, so this is you are in PL SQL prompt. Okay, so you can go /d and hit enter. Sorry, not /d. Exit, I think. So normally you can give exit, or I'll give control D. Okay, so directly if you give control D, it will /q actually, not /d. Okay, so you can get out of the PL SQL prompt. Okay, so if you want to connect to a specific database, you can give -d. There are different options, right? To -d, your database name, -u, your username, -p, port. Okay, capital W. Okay, so if you give capital W, it will prompt for the password of the user. Okay, so I'll give Postgres. Okay, so you see it's connected to the test database. So while connecting from the PL SQL only, okay, you can give the database name, port, host also. Okay, so you can give like -h and mention the host name. Okay, so you can connect to that particular database. So these are the different connection options. Okay, so and you can go like pgctl stop, server stopped, pgctl start, server started. Okay, so you can use the pgctl start and pgctl stop. Okay, so once the database is created, okay, so you can connect to the database. Okay, so and you can create your own schemas. Okay, so let's say, okay, so let me connect to the database now, again to the cluster. Okay, so what databases I created? I created test database. Let's say I connect to the test database. Okay, so what are the schemas I have now? So I have the public schema, only public schema now in this database, in the test database, right? So now you create a table, create table, emp id integer. Okay, and /dt will give the list of relations. List of relations is nothing but list of tables, and it is showing what is the schema of this table. It is a public schema. So you can give /dt plus also. Okay, so you can see the size of the table also here. So if you give like /dt plus, so you can see here owner is Postgres, persistence permanent, size is 0 bytes. Okay, so if you want to see the description of the table, okay, So just like describe table name in Oracle, okay. So in Postgres, you want to see like what are the columns, what are the data types, all those things, okay. So you can use d plus, give the table name. So you can see here, okay. So column is, you have only one column in this table, okay. Or you can give like just /d and emp. So it will just give this few things, okay. So otherwise it will give more options. And also the good thing here in Postgres is, so when you describe in Oracle on the table, so it will just show the table description, right? So, but here, the good thing is, okay, so let's say create index, okay, emp underscore idx on emp, okay. So see here, it will show whatever the indexes you have on the table, it will show the indexes list also. If you have any constraints also, it will list out constraints. This is a good thing, right? So instead of querying whole lot of things, you can just give this and you will come to know like what is the index name and what is the type of index and on which column that index is created. So this is one of the good option. You can describe that. Okay, just with the description you're getting. Okay, so now this is the public schema, right? So what I'll do here is, let's say select current underscore schema. So this is a public schema. So what I'll do here is I'll create a schema. Okay, a schema is created. So what is the you see the schema, it is showing now two schemas. Previously, it was showing only one schema, that is public. Now it is showing the schema test. Okay. So what I'll do here is create user test. Okay. So I created a user test. So you see now two users. So Postgres is by default, one of the user is created and one more user is test user I have created. Okay. So now you see here, there is a user with test, there is a schema with test, right? Username and schema name are same here. Username and schema name are same. Okay, so now you see detail still showing the public schema. Okay, so let me disconnect and let's try the other way. So maybe I'll use the, okay, so it's showing the schema public and name is emp. So what I'll do here is I connected with the user test, right, to the database test. So let's try to create a table. Create table emp underscore bkb, let's say. So will it be created? Oh, so id. So table created. Okay, so you see here, so still it is created in the public schema. Okay, let me disconnect here and we'll do one more test here. Let's connect with the Postgres. See here, this is one more thing. Okay, so you can get the help. Okay, so just give /help. Okay, so you can see what all the options you can have in the Postgres. So if I do like /h, okay, like create schema. So you see here what all the options that are available using means with the create schema. So you can see all of the options. Okay, so if you can give like create database, anything. Okay, so just specifically, okay, if you just give /h, so it will show like base options. Okay, so on top of that, if you want to see specifically like you will have like drop schema or alter schema, anything. Okay, so you can give that particular thing. So it will show the information of the clear information. So command with command, you can see here alter table space, you can rename the table space, you can change the ownership, you can change the options, reset the tables space options, all these things will be displayed for you. Okay, let's see for grant. See here, you have a lot of grant options here. Okay, so grant, select, insert, update, delete. Okay, grant usage on database. Okay, grant connect to database. Okay, so here, okay, so by default, so now if you see, okay, so I told, right, so whenever you create a database, so by default, okay, all users are able to connect to the database. So I created a new user now, right? So the new user is, what is that new user? New user is test. Okay, new user is test on the right. New user is test. Okay, so what all databases you have? Okay, so you can see here you are now connected to database test as user test. So I haven't granted any permissions on this test database to that newly created user, right? So if I create new user also, okay, so let's connect Postgres again. So I'll connect to Postgres database or any database. So it doesn't matter, okay? So it doesn't matter from which database you are creating the user. Okay, this is bit confusing part who are there in Oracle. Okay, so why means, see in Oracle, so if you see, mainly probably it may not be confused for developers, probably who are in the admin side. Okay, you create a users in the database. Okay, and whenever I create, let's say like pluggable database. Okay, you have the concept of pluggable database. Okay, whenever you create a user in that pluggable database, okay, that user will exist in that database only, right? So in whatever the database you create the user, that user you will expect in that database only. But here, okay, you can create the user from any database, and that user, okay, will exist, okay, on database layers, right? So we talked like the users are same at the level of database, so you can grant the permissions on multiple databases. Okay, so it doesn't mean that, let's say I created database by connecting to test database, let's say, or Postgres database. It doesn't mean that that user exists in that Postgres database itself, or that user can connect to only one that Postgres database, or I can say that user can create the objects in that database itself. It's not like that. So the user can get permission on multiple databases. Okay, and users can create objects in multiple databases. Let's say database A, B, C, D. So you can grant permission of for one user to A, B, C, D. Okay, this user can create objects in A database, B database, C database, D database. Okay, so but yeah, so when you have to access that tables or objects, you have to connect to that database. Okay, so to whatever the database you connect, you can see the objects of objects existing in that database only. And also the schema also come into the picture. Okay, so that we'll discuss. So if you see here, so what I was telling, so yeah, so I connected with to Postgres database as a Postgres user. Okay, create user. Okay, so we created user test, right? Okay, so maybe like what you can do is Dave. Okay, so we have a user created. That user is Dave. So now you exit from here and you connect to the test database. Okay, so database test, and you connect as a user Dave. Okay, so you see here user is Dave and we connected to the test database. So I haven't given explicitly the connect privilege, okay, to that newly created user Dave on this database, but still the user can connect. So that's what I referred in the previous slide. So if we, where is that create database? Okay, this you can see here. Okay, so revoke connect on database name from public. Okay, so if you don't give this once you create the database, okay, remember the newly created users can connect to the database. Okay, so if you come here, okay, so if you come back to our VM, password is Postgres, revoke on the database test from public. Okay, so now if you try to connect with this user and see, password is 1, 2. So you can see here, permission denied for database test. User does not have connect privilege. So this is one of the important thing. Okay, so you have to remember. Okay, especially when you create a new database. Okay, and if you don't want to give the if you don't want to give access to all the users, so probably you may revoke, because it's by default coming to public. The permission is getting to the public, so everyone can access. So if you want to have some restrictions on the database, okay, so maybe you can revoke and explicitly grant the connect to a specific users only, so that the users can only that specific users only can use those databases. Okay, so so when you are creating the database in the cluster, okay, it is not required. So I mentioned you can create the database from the cluster and outside of the cluster, right? There are two options. So if you see here, where it is, create DB. Yeah. So here we are, so far we have created a database using the by connecting to the cluster. Obviously, when you connected means you connected to a specific cluster, right? So, and when you create a database after connecting to the specific cluster, so obviously that database will be created in that cluster itself. No need to explicitly mention the cluster name. So, but we have a other option of.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Creating database at the OS level, right? Where you can create DB option. Yeah. So you see create DB, okay, creating the new database. So since this is a OS level, so here you get the option of mentioning the cluster. So if we go, okay. So yeah, so you can see here, you can mention the port name. Okay, so while creating the database using this create DB option. Okay, so create DB, you can mention if you have any particular table space. Okay, so we haven't used that table space in now, so I'll show that. Okay, so later, okay, how to create the table space, all those things. Okay, here, yeah, so whenever you are creating the database outside of the cluster, means outside of the cluster means using the create DB command. Okay, so you can use port, just like how we use the port, okay, when you are starting the cluster or when you are connecting. So you can use this port option. So port will be unique, definitely, right? So if you use like whatever the port you are using, so it uses that cluster and it creates the database in that cluster. Like let's say, so create DB, okay. So, and you can use any of the options, table space, all those owners, all those things. Okay, so what I'll give DB name is maybe prod. Okay, so and connection options, -p, what is that, 5434. Okay, so I don't know whether it did not give anything. Yeah, created in the same cluster of 5434. So I connected to show port, I think 5434, right? So yeah, so that's the good question. So when you are using the create DB only, yeah, so you can use that option of port. But when you create using the create database command after connecting the cluster, so that is not required. Obviously, you connected to one of the cluster, right? So yeah. So coming to the table spaces. So here you see, okay, whenever you created the database, okay, so and so these are the catalog views. Okay, just give /D capital S, so you can see all of the catalog views, like just your data dictionary tables. So you can see all of these are the catalog tables in Postgres. Okay, so if you use the EDB version, okay, so the enterprise version, okay, there is one advantage when you use the enterprise version. So one advantage basically is for the one who is already working in Oracle. Okay, it may not be the advantage for other DBMS, but who are working in Oracle, so you'll get one advantage if you use the enterprise version. Why? Because in the enterprise version, you get, okay, so enterprise version, we also call as advanced server, Postgres advanced server. So there you get the compatibility of Oracle. The compatibility of Oracle in the sense, it's not like something, when I say compatibility, it's like you can see data dictionary tables, some of the data dictionary tables which we use in Oracle, like maybe user underscore tables, okay, user underscore or DB underscore. So some kind of data dictionary tables you will get in the enterprise version also. So if you are not much familiar, at least at the initial stage, so you can rely on that Oracle data dictionary tables, but that only comes with the enterprise version. But here, yeah, so in enterprise version, you'll get lot of, means you see few views which owns by sys user also, and which you can see like DB underscore like that. Okay, so here we have PG underscore database. Okay, so if you see, select OID that name from PG underscore. Okay, so you see here, okay, so OID, object identifier or database object identifier. Okay, so if you see, we have created a test database, we have created a prod database, right? So previously we have other databases. Okay, so if you go to your, where am I? Okay, in PG data one, CD base. So if you see here, okay, so how the data is laid out in the OS level. So when I created the database, it creates one object identifier is just a numeric value associated with that database. With that same identifier, it creates a directory in the data directory. So in the data directory, in the base, you can see the directory created with the same object identifier. You see test 16384, 16384, prod 16395, 16395. So under this, if you go, okay, so there are objects in this. You can see there are a lot of files, okay, so created in this. Okay, so this is what test database. Okay, so like that, okay, so it will be there. So for every database, you'll have the directory created, and in that directory, what we can say, all the files will be created. And every database, I told, every table or index will have the file node, so that we'll discuss further. Okay, and it will be something different. Okay, so let me connect to other cluster basically. Okay, so I did not create the table space. Okay, so all are pointing to the default table space. I thought I created some table space, non-default table space. Okay, so we can create a table space. Okay, so if you see our own table spaces, we can create. But as of now, so we have a default table space and global table space. So if you want to create a table space, okay, so let me see if I have any directory. This probably, let me use the temp directory. So temp pgts. Okay, so let's connect to. Never use this kind of naming conventions because it has a lot of catalog views which starts with pg underscore. Okay, so that's the reason. So I'll use this reverse tgs underscore pg. So table space created, okay, db plus. So you can see here. So whenever you create a non-default table space, so you can see the location here. For the this table spaces, by default, it will be the data directory, right? So, and you can use this table space while creating the databases. So, but before that, okay, so what we'll do here is, okay, so we'll go again to the base directory, not base directory. Okay, so you go to pgtb table space. Okay, so basically when you create a database, okay, create database QA. What is the table space? TS underscore PG. I think this is not required. Yeah, so I connected to, I think, the other cluster. So let's connect to this cluster and see and run this. And if you see the list, so you see here for this database, it shows like this is the table space we have used. Okay, and this size. Okay, so you can see here. Okay, so I connected to the cluster. So we have three databases: Postgres, prod, and test, and two default templates we get. So what I did is here. Okay, so I listed out the users. Okay, and I created a new user, QA. Okay, so by default, if you see, I created a user and I tried to connect to one of the database. So here, this command is connecting to this database as a user QA. Okay, so I'm trying to connect to the database, test database, so which was already there, and QA user which I just created. So if you see, you got an error like permission denied. Okay, so we don't have that user doesn't privilege. So later, okay, so I granted the connect privilege to this user. So, and we are able to connect to the database. Okay, so we can check like how we can check as with which user you logged in and to which database you are in. So you can check with this, select current user and select current database. So now once you connect to the database, okay, so try to list out the schemas. Okay, so what are the schemas that are existing in this database? Okay, so you can see here. So right now we have a schema. Okay, so public and test schema. Okay, so now let's check the tables actually. If you see DT. Okay, so now you can see here. Okay, so this user can list out the schemas. Okay, so we connected as a QA user, and this user can list out the schemas and can see the relations also which are there in the public schema. Okay, so you see here, okay, the public schema this user can see, but let's see here. Okay, DT EMP. Okay, so let's see select count of star from. So yeah, so listing wise you are able to see. Okay, so you are able to see the schemas, you are able to see the table, you are able to see the description of the table also. But when you try to select the data from that particular table, so you got the permission denied. So now, so there are what are the things we have? So only the user connected to the database and the user was listing. So when it comes to the listing wise, okay, so the user can see the schemas and tables, but not select. So let's say this user want to create a new schema. Okay, so schema is different than user. So that's what we discussed in Postgres. Okay, schema is not same as the user. So let's create a schema. Okay, so create schema QA. So I'm just creating the schema as QA. So permission denied for database test. So this user does not got the permission to create the schema in this particular database, test database. Okay, so now, so we connect as a Postgres user who is a super user. So what we'll do here is grant create on database test. So we have granted create on the database. Okay, so test to the user QA. So let's connect again with the QA user. Okay, so and let me create a schema. So the user is able to create the schema now. So in which database? In the database test. So let's create a table. Okay, create table test. So the table is created. So now let's search here. Okay, so here you see we have created a schema QA and we created a table test, and you see by default in which schema it has created in the QA schema. Okay, so let's again create one more schema with the same user. Okay, so let's give something like dev schema. Okay, so create schema dev and create table test underscore one, and let's search here. So you see here, okay, so by default, whatever the tables I'm creating, so it's getting created in the schema QA. Okay, so previously it was not the case. So if that used to be created in the public schema. Okay, so if you have a schema name same as the user name, then that will be your default schema. Otherwise, public will be the default schema. Okay, so here you can see we have the QA schema. Otherwise, it would have created in public. So we have, okay, so this user has created now two schemas, QA schema and dev schema, and QA is default. Anyhow, whatever the tables you create, that will be created in QA. So what if I want to create tables in the other schema? Okay, so let's list out the schemas here. So you can see how many schemas you have in this database. You have dev, public is default, QA and test. So dev and QA is owned by the user QA, right? So now this user though is the owner. Okay, so user is the which user? QA is the user, right? Okay, so but default will be the QA schema. So if you see show search path, okay, so this tells you, okay, so basically if you see the search path, you have dollar user and public. So dollar user is nothing but it represents with which user you connected. Okay, so we connected with the QA user and there is a schema with QA, right? That's the reason why. So we have it just represents the QA and public. So if a QA schema is there, so it will pick up that as a default. So if QA schema is not there, then it will pick up the public as the default. So now we have the other schemas also like dev. Okay, so set search path to dev. Okay. Okay, so now search path I have set to, it was previously dollar user public and now I had set to the dev user. So now let's look for the tables. So there are no tables in this schema. Okay, so explicitly we set the search path to dev. So now let's create a table. Create table day1. Let's go. Okay, table created. So now you can list out. So in which schema this table is created? So in the dev schema, so this table is created. Okay, and the owner is given. So here what I was trying to say is one user can create multiple schemas. Okay, so one user can create multiple schemas and can create tables in multiple schemas. But here, what would be the default schema is the schema name, which will be same as your username. That will be the default schema and the public. So if you have the schema name same as username, so that will pick up or else public. Otherwise, if you have other than these two schemas, okay, let's say you created some other different schema, then definitely you have to set the search path to that schema and then you can create a table. Okay, so that it will create the table in the whatever the search path you have specified. Otherwise, let's you can do one thing. Okay, so maybe you can see, so you can specify the schema name explicitly otherwise. So if you see here, okay, let's see, we have already dev underscore test in this. So the one which I have created, so I have specified the schema name as QA. So you see by default, it lists out the tables which are there in the schema dev only because I have set that. So if I want to set again search path, so I can set search path to the set search path to QA and just list out the tables. Okay, so you see, so we have same two table names. Okay, dev test, but in the different schemas. Okay, so this is how user and schema mapping will be. Okay, one user, okay, in the database. Okay, so here I already told about the hierarchy of the objects. User does not exist in the database, right? User is at the cluster level. User, database, table space. These three are at the cluster level. So this user have the permission, connect permission to the database test. Okay, and also this user has got the permission, create permission. So create permission means we can create the schemas, create the tables. Okay, so the same user can create the schemas in the different databases also. So only thing is that user need to have two major permissions. One is the connect permission on that database and one is the create permission on the database. Okay, so if you have these two permissions, okay, then the user can create the objects. Okay, so these are the two main things. So next, how you can grant the permissions, okay, for the other users. Okay, so let's say there is a other user. So let me open the other terminal. So let's create one more user here. So we have dev QA test. Okay, create user maybe pre-prod. Okay, so we have created a user pre-prod and let's see if this user, obviously this user cannot connect, right? So pre-prod database as not this database will be test and user is pre-prod. So what will give? What is the database? So now let's connect to this test database as pre-prod. Okay, okay. So this user is able to see the schemas what are exist in that database. So test database we have the schemas. Okay. So now if you see here, okay. So DT. So it only lists out the tables in the public schema. Okay. So by default, if you see, you get the permission on the public schema. So when I say there's one thing here, okay, you may get confused. So when I say, okay, by default user get the permission on the public schema means it's just to list out the object names. Okay, so if you see the owner, okay, so owner is okay, the Postgres and owner is test. Okay, but with which user you connected as a pre-prod user. Okay, so but if you access this, okay, from public.emp, so what say it says like, okay, like, so permission data. Okay, so remember, so when I say the permission on the public schema, so it's not the permission to view the objects of the public schema owned by the other users. Okay, so it's not these are owned by the other user, right? So just like in the directory you have the ls-lrt. Okay, read permission means you can just see the tables. See the tables in the sense list out the table names again. So there is a difference. Okay, not getting the data. So now, okay, so this user connected as a pre-prod user. Okay, so if this user want to create, okay, there is already schemas, right? So what all the schemas you have? Okay, so we have QA schema and dev list of schema, dev, QA, and test. Okay, so what we'll do here is we'll connect again with the Postgres user. Okay, so grant usage on schema QA pre-prod. Okay, so now what I gave the grant usage on schema QA to pre-prod. Okay, so now let's connect with the pre-prod user. Okay, so let's say set search paths. Which one I have granted? I have granted SQ. So you can see here. Okay, so search path is I have set the search path as QA. Okay, I can see the tables. Now let's set the search path to dev. Okay, and see. So you see here the difference between the output between the QA and dev. Okay, so in dev also we have the tables, right? So dev underscore test. So if you come back here, okay, so this table is existing in QA schema and also in the dev schema, right? But two are different tables. Okay, so name is same but two different tables in two different schemas. Okay, so if you see here, when I set the search path to QA, so it listed out what all the tables present in the QA schema. But when I set the search path to dev, so I did not see any relationships, though there is one table in that. So why? Because I have given the usage on only QA schema. Okay, so I did not give the usage on the dev schema. So that's the reason. So what we'll do here is, okay, so we'll set the search path to QA again. Okay, so then let's create table. So pre-test LQ. So you can see here. Okay, so what error you are getting? So you are getting like permission denied for schema QA. Okay, so the reason is the who is the owner of the schema QA? The owner is QA. So when you give the usage, okay, so this user can just see the contents again. Okay, so if you see, let's give the QA dot. Okay, so by default, so you get usage on public schema, right? So when we checked. So we did not give explicitly any usage permissions on the public schema. Okay, so that's why. So by default, you are getting the usage permission on the public schema. So usage means you are able to list the objects in that schema. That's it. Okay. You are not able to see any tables. I mean, read the data from any tables, any DML, any DDL activity. So you cannot perform on that objects. So in that case, so you have to explicitly again give the permission to that user. So grant select on this particular table to that user, then only you can see. So now let's grant the permission. So let's connect with the user QA, right? Grant select on Dave underscore test. So what is the user? Okay. So now let's connect again with pre-prod. So you can see here. So extra thing you have here is usage. Okay. So one thing usage. Okay. And here, what if you don't have the usage permission? Okay. So if you have only the select permission, so that's one more thing, right? So what we'll do here is let's connect to Postgres. Okay. So now what I did, I have revoked the permission. Okay, so I have revoked the usage permission on the QA schema from the user pre-prod. Okay, so let's connect with the pre-prod user. Okay, so what you are getting here now, so you are getting again the permission issue. So we have though granted the select permission. Okay, so to the pre-prod user. Okay, so previously if you see, you are able to get the permission. I mean, you are able to see the data, but when I revoke the usage, I did not revoke the select permission. So here I revoke the usage permission from the user on that particular schema. So then I tried again the count. So we are getting the permission denied again. So basically here, so you need to have the usage. The first is usage, and on top of that, any DML or any select permissions you have to grant. Okay, so that is important. Okay, so far it's clear. So user and schemas. Okay, so and if the other user want to have the permission on that particular tables, so first the other user should have the usage permission on the schema, and then the select or whatever the insert any other statement should come later on the usage. So if you just use select or any other permission without usage, so it will not work. Okay, so this is one thing you need to know. So so you can, yeah, so usage is important. Okay, so next is whether the other users okay can create. So now if you see, okay, we can see the contents in that schema, and we can on top of that explicitly that user gives any permission. Okay, so we can get the permission on the table. So but we are not getting the permission to create a table, right? So if you see, we are not getting the permission to create a table. So how the other users can create the objects in this schema? Okay, whether the other users can create objects in this schema. So let's see. So we'll just connect as QA user to this database. And what we'll do here is, okay, so we have granted, so grant create on schema QA to pre-prod. Okay, so now connect as a pre-prod user. Okay, then let's try creating a table. This table is created. So there are two things. Okay, now you got it right. So when you have the usage, it just lists out, and on top of that, if some objects are on, okay, let's see here now. Okay, so you see here, okay, dt I have given. Okay, so when I have given dt, so you can see here, okay, so it has listed out the public schema. So we know already the default schema, it went into the public schema. Okay, so now this user has got the permission to create the tables in this database. Okay, and we created okay, so on in public schema. So probably what we'll do here is we'll give qa dot pretest. So table got created, right? So means you are able to create the table in the QA schema. So let's say DT. Okay, so it shows on the public schema, obviously. So what we'll do here is set search path to QA. Okay, so and see the DT. So you see here pre underscore p test. Who is the owner for the table? So pre prod. Okay, so it means now this schema, the QA schema, in this schema, QA user can create the objects and pre-prod user also can create the objects. So it's not like in one schema, only one user can create the objects. Okay. So in one schema, multiple users can create the objects and the ownership is different, right? So this table is owned by pre-prod in the same schema, QA schema, and this table is owned by QA in the QA schema. So it means there are multiple objects owned by multiple users. And yeah, so on top of getting the permission, so each whatever the user you connected, so you can access that tables obviously as a owner. But if you want to access the objects of the other user, okay, then obviously you need to get explicitly permission on that specific object. So here, if you compare in Oracle, so we have the object level privilege. So object level privilege will be as it is here. Okay. So object level privilege is as it is. Only thing is extra thing what we are seeing here is the schema actually. Okay. In Oracle, you don't have the concept of schema itself. You have the user and then connect, you create the objects. That's it. But here you have the concept of schema. So if you connect to one database as a user, okay, so there are schemas again. So public schema and $user schema. If you have schema name same as the user name, and you can create multiple schemas. So this user can create.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.
Objects in a schema in multiple schemas in one database. Again, the same user can connect to other database if that user has permissions again on connect and then create and then okay. Once you get connect and create, you can create the schema and you will become the owner of the schema, obviously. Then you can create the table. So this is how it works. Bit confused, but yeah, the relationship between the user schema is something like multiple users can get the permission on the same schema ownership. Okay, so you can create objects now. So if you see dn, okay, so the owner of the schema is QA only. So if you see the schema is QA here you are seeing. Okay, so since this schema is created by QA user, so by default the schema ownership will be with the QA user itself. Okay, and there is no explicit like if you write create schema on that schema name, that's it. You can set the search path and you can create the tables. No need to grant that grant create on schema. So that is only for the who are not the owners. Okay, owner by default anyhow get the permission on that schema. Ownership will be with the this user only. Okay, but the ownership of the tables, okay, will be different because this table is created by this owner, that user I mean to say. So now you should see here, okay, so du, okay, so du list out the users and you see Postgres is the owner. Okay, so and you can see this user has got all the super user, create role, create db, replication, all the permissions this user has got. So but the other users you can see, okay, so we don't have any permissions, right? So if you connect with which user you are in now, so you are in a pre-prod user. So if this user tries to create a database, so obviously this user will not get permission. Create a database. Do you have the database with pre-prod? Right. Database pre-prod. So permission denied to create a database. So because these are the normal users. Okay. So you can make you can give the roles while creating the users. Okay. So or I can alter now. Okay. So pre-prod user alters user pre-prod. Okay. With create DB. So that should be done as a super user again. Okay. Connect Postgres. Okay. Now let's give. Okay. So now you see DU. So you can see here the list of roles. So create DB role is there with the pre-prod user now. Okay. So see pre-prod. So now you create database pre-prod. So database created. You can list out this database. Okay. So here you can see. Okay. So pre-prod is the database, and you can see here the access privileges of each database. So here what are the access privileges of pre-prod? You can see anything, but here if you see in the test database, obviously you have the Postgres user. Okay, since that user is a super user, okay, that user will get connection permission. Okay, connect permission to any database. So then you have a QA user permission, and you have pre-prod user. So you got three users who can access this database. So now pre-prod is created by which user? This user is pre-prod, and you can see the ownership of this user is pre-prod. Okay, again you need to give the Postgres. Okay, so if you see, so super user. So obviously, okay, so if you give no login, so obviously, okay, so you will not connect as a with that user. So role QA is not permitted to log in. Okay. So this, if you want to restrict any connections from a specific user, if you are doing any maintenance activity like that, so for a certain period of time, so if you don't want login, so probably you can just disable the logins for that user. Okay. So I'll just give with login. Okay. So then I want to show, I mean, that's the schema. Actually, all of your catalog, you can see users, sorry, catalog tables exist. So PG underscore user is the catalog table. So where you can get the information of the users. Okay. So if you see here, select username, comma, mainly the password. So usually, okay, so you can see here, password is encrypted here. So if you see the help of the create user, okay, so by default, it will be the encrypted only. I think no encrypted also you can use. I need to check that. So that the password will be visible actually. Okay. So that also, let's create, let's try, not sure. There is something that I'll see. Okay. So there is a way, I think. Okay. So which I remember, I'll get done. Okay. So yeah. So that is about the user, and you can create roles also, just like how you create roles in Oracle and other databases. Okay. So not login. So the roles also will be listed in when you give /du. So the roles also will be listed. Okay, this is not exactly the user. Okay, so this is the role. Create db, comma, create, no, not this, not granting here. So we have to alter same as you. Sorry, alter role underscore one. Okay, with create db. Okay, create role. Okay, so now if you see du, so we can say create db create role. So now what I'll do here is grant role underscore one to test. So now you see here. Okay, so previously it does not have any roles. Okay, so now I have created a role explicitly, and I have assigned these all things, and then I granted this role to this user test. And you can see here member of role one here. Okay, so what the create role create db is there. Okay, so that will come by default to this user. So current underscore database. Okay. Okay. So on test, you have Postgres QA pre-prod. Okay. Test and Postgres. Then you grant, but just a second. You want to create database. Which user is connected? Up. One thing we have to do here is one thing I forgot. Set role underscore one. Okay. Then you run schemas in that database. So remember, okay, just connect will only allow. Again, if you want to create any new schemas, obviously you will get one schema. Okay, what is that? Public schema. So if you want to create any other schema, so you have to again explicitly get create schemas and create on the data. There is two difference actually. Okay. If you get create permission on the database, okay, you can, okay, let's say like I have a database X. Okay, database X is created, and on that X database, Abhinav user got the connect permission, and I also got the create permission on the X database. So I can create a X database and I can create schemas. Okay, and I will be the owner of that schema and I can create the tables. But let's say there is a user Y and user Y has some schema, okay, a schema. So in that case, I need to also get, if I want to create the tables in that a schema owned by Y user, then I need to get create permission on that schema so that I can create the table. So, but if you in your own schema, you just need create permission on the database level. That's it. You can create on fault. It will come with the lowercase. Okay. So people who migrate from Oracle to Postgres, okay, um, by default, the tables will be created, okay, in the lowercase. Okay. And there is an option. So while migrates, remember, you need to use the same case when you are using referring in any other state. Okay, so there are some parameters. Okay, a lot of parameters actually. So we'll go through some of the parameters here. So you can see parameter values can be like boolean, integer, floating, string, enum. Okay, so we already used initdb, okay, to create the cluster. Okay, and we have already seen that alter system. Okay, that's fine, but from the database also you can set using alter system set and give the command. And if you want to set at the session level, you can give alter session set workman. And for default values, you can give like default. When you use this kind of statements, remember that value will be recorded in this file. And Postgres recommends not to make any manual changes to this PostgreSQL autoconf file. Okay, so that is important. Okay, running on the same machine. Okay, and default port for Postgres is 5432, and for the license version, I think it's 5444. Okay, and max connections. So these are the maximum simultaneous connections. Okay, at one point, how many connections it can take? So the default is 100. So if you are creating a database or cluster, so you need to consider this, how many connections your application can initiate. So based on that, you can change these connections. Okay, super user reserved connections. So this is a good thing actually. Okay, so default is 1 minute. So if you think that 1 minute is more for the timeout, probably you can reduce that. Okay, so whatever you want. Okay, so these are the SSL files. Okay, secure socket layer for connections. If you have any certificates, those kind of things. So this temp buffers. Okay. So workmem. So workmem, we have already focused few things on the workmem, right? So whenever you use the sorting kind of thing and joins, okay. So this workmem will be used, and this is a private memory, right? So for each session you connect, so you have this much of memory allocated, and it can use this much. If you use beyond this, definitely it will just spill to the temporary disk files. Okay. So maintenance workmem. So we know auto. Okay. So next is temp file limit. Okay. So here we have seen workmem, right? So if so and so table. So how in what quantities basically that data is read? Okay, will it read in row by row or how it reads the data? Any idea? So it's in pages, right? So it's in, if you take an Oracle, so it's in, we call it as a blue. Right, you can prove that my query is not an optimized query. Okay, and you see whether it is going full table scan and whether it's going index scan, something like that. So directly what you are going to achieve with this, okay, let's say my table is going with the full table scan. Okay, it's not using the index. What would be your idea, or how you can tune that query? Let's say you use the index, you think creating the index. So creating the index and without the index, what are the two different, what happens using the index and what happens without the index? Okay, so here you go, like, yeah. So basically, what the underlying thing you are doing is you are trying to reduce the number of pages, okay, to get the output, right? So that happens through the output, right? So that happens through the index when you use some kind of filter classes in your statement, obviously, right? So if you go with the full table, obviously that you can't reduce. So it depends on the query to get your final output, right? So I give like select star from EMP where EMP ID is equal to 1234. Okay, let's say my table is using 100 pages. Okay, if there is no index, so obviously it has to scan all the 100 blocks, but again, eventually it has to give only one row as an output for me. Okay, so unnecessarily scanning, okay, unnecessary scanning is happening at the OS level, and the underlying resources are more used. When I say resources, mainly the data. So data resides on the pages. So if you access more number of pages, DML activity, so definitely you will see some performance degradation when you set the hot standby or archive, those things. Okay. So fsync, okay, so it's syncing to the database. So turn this off to make your database much faster. Okay, and silent in case of system crash. Okay, so default is on. So but there is a trade-off for this. So there could be any corruption if any system crash happens. So these parameters basically it would be good to set to the default level only. Okay, because there are chances like you may face a different kind of issues, okay, other than the performance. Okay, so wall buffers. So you see here how much of wall buffers you can use. So in the shade buffers you have, so same like that you can also have how much amount of memory should be used from the shade buffers. Okay, so this you can go with the default value itself. Checkpoint segments. So maximum number of 16 MB wall file segments between default is too small. So here, okay, so let me show you. So here you see these are the wall segments, and if you see here, maybe I can put in this way. So you can see here each wall segment is 16 MB. Okay, so this is what there actually it is representing. So how big your wall segment should be. So you can go with the default size. Okay. Okay, so this is related to checkpoints. Okay, so main thing is, okay, yeah, so these are related to log files. Okay, so log destination. So I have already shown you the log file, the default log file location. In the PG data you have the log directory. In the log directory you can see the all log locations and log file name. If you see here, okay, we have seen the default log file format, right? PostgreSQL, year, month, and date. Okay, and allows regular log rotation. Okay, so log rotation also will be there. Here you can see log rotation age. So automatically rotate logs after this much time. So you can rotate automatically. Okay, so means for every 7 days or for every 30 days. So if you want to automatically remove the old log files of the database, okay, so you can set a particular time to this. Okay, based on the age you can put, or also based on the size also. So you can see automatically rotate logs when they get a particular big size of. And for all these main things is logging collect. Okay, whether you want to enable logging or not, okay, that is decided by this logging collector. Okay, so if you don't enable this, okay, definitely, okay, so you don't even get the logs itself. So if you don't get the logs, then there is no point of setting the other parameters itself, right? There won't be any log file name, There won't be any mode also. Mode is like the permissions. Okay, so in Unix you can see 0600 means read permissions for the user and no permissions for the group or for the world. So these are related to log. So in this is the main thing actually for you guys. Okay, this is like what kind of messages you want to log in. So in the database log files, each message will be flagged with different kind of what we can say, like whether it's a notice means it's just it is saying something. It may not be the error in your database or nothing actually. Okay, it's something like notice kind of thing, warning or error. Okay, so this is when you see a warning in the database. Okay, so that messages will be logged in, so that you can define. Okay, warning error. The last one, if you say, this is a very important parameter when it comes to the queries actually, log min duration statement. So this parameter you can use to collect the information of the long running queries. Okay, so let's say you have a database and you want to, your criteria, maybe you have a criteria that my query should run within like maybe 2 minutes. 2 minutes is the maximum time that any query should run, and no query should run beyond that. So here you can mention, okay, time. Okay, let's say 2 minutes. So whatever the queries runs beyond the 2 minutes, that queries will be logged into your database log. Okay, so this is a very important thing to track. If you see any issues with the database, or if someone complains that the queries are running long, or basically if you are testing your own queries probably, okay, and you want to capture what are the queries running long by having certain particular threshold time, maybe that you can put here, you can capture that in your database logs. Okay, so log connections, log disconnections. Yeah, this is basically if any successful connections happens to your database, so you can log that. But this is we won't usually use this, because if you use this, your log file will grow bigger and bigger, because you may get a lot of connections to the database. Okay, so for every connection, if it tries to log into your log file, so your log file will grow like anything, and there it will show with which user the user has connected. Okay, what is the IP address of the user, to which database that user has connected. So that kind of information means the client information. Okay, which user connected, what database, what time. So that kind of information if you want to gather, okay, so you can go with log connections, and log disconnections is opposite to that. So whenever the disconnection happens, okay, that information will be collected, and you can see the duration of the session. So like maybe this session has been connected for the last 1 hour or 2 hours, that kind of duration also you can see. But basically this is not requirements. Whenever you enable this, just make sure you have the enough space, okay, because your log file will grow. Okay, log line prefix, log duration. So log duration of each statement. Okay, so if you give log duration, okay, and again for every statement it will log in that statement. Okay, this statement has run this much of time. So in instead of that, you can go with this log min duration statement just to capture the long running queries. So if you go with log duration, okay, so it will be like more for each and every statement how much duration it takes. So if your database is very busy database, so your log file will be more actually. It will grow. Log error verbosity, so can also selectors or verbose. So error, if you want to get more verbose, okay, so you can go with that. And then log statements. Okay, so legal values are none. So if you want DDL, okay, and other data modifying statements are all. So basically it is none, means no DDL, no DML statements will be logged in. Okay, if you want to log in every DDL performed by any users, or any DML also if you want to record in your log files, you can go with this. So these are all, you can say none, because usually we don't require all these things, but in case for a particular time you can set, okay, if there is a problem or if someone is doing certain kind of DDL or DML, so you can capture that. And you can use this for kind of auditing also in case, okay. Log temp files, okay. So obviously if your work mem is not sufficient, we already discussed, right? So it creates some temp files. So if you want to uh, see that information of the temp files, okay, so you can see, okay, you can mention like, okay, if your temp file reaches this much size, then you can log in that kind of size you can give, so that you can also get the information, right? Like if your database is creating more and more temp files, obviously there could be a issue with your workman, okay. So or maybe your statement, it can be it can be like either you can use workman, or if there is any chance of optimizing your queries, so probably you have to look into the queries and try to see if there is any possibility like that. And this is about the log checkpoints, okay. So internal thing, this will not touch basically background related, okay. Search path we have already statement level, right? So we have already discussed about the search path, okay. And default table space, temp table space, name of the table space in which two objects are created by default, okay. So default table space usually it will be for the database level, okay. So don't think that, okay, so if you are a Oracle person, maybe you think that table space is something related to a user or table level, right? In Oracle, so what you do is you create a user and you can allocate multiple table spaces to a single user, right? So user one can use data, user one can use index, user one can use this, so many table spaces you can use. But here it's not for the user, it is for the database, okay. So when you are creating the database, we are just creating, where we are creating create database name, that's it, right? But you can I think I already shown, like when you are creating the table space, sorry, database, you can mention the table space also, or you can change the default table space parameter probably to a specific table space, so that obviously it will, when you create a database, so that table space will be picked up. So don't get confused, it is not for a user or table level, it is for a database level. Temp table spaces, so this I'll show, okay. Temp table spaces, okay. You can even allocate one temp table space where the temp files can be created, okay. So next is statement timeout, okay. So if you don't want a statement to be delayed, okay, like maybe 1 minute or 2 minutes, so you can just give some short time so that if something happens immediately it can time out. So then we will discuss vacuum related parameters. So this is basically the cost of the vacuum. It's not about the your statement cost or your query cost, but it is related to the vacuum cost, okay. So and okay, these are all the vacuuming related. So this is like in PostgreSQL you have all parameters, right? But you can redirect your configuration file, like in the postgresql.conf you can put include and you can put some other directory and some other file, okay. So it will direct to that file, okay. You can put the directory here and you can put the file name here, okay. So basically in postgresql.conf you may not have all the parameters, but it will direct to some other directory, and that where you put the file name, so there you will have the actual files. So this I'll show. Basically you can divide also, means for PGA HBA or for logging I want separate configuration file, for vacuum I want separate configuration file. So you can divide the configuration files in different files actually. So here, okay, so we'll go through some of the data types here, okay. So I think here most of the some data types you are already maybe aware of that, like integer data type. Okay, so in integer data type we have three types basically. Okay, so if we go, yeah, so small int, integer, big int. So the size is different. Basically, you can see the storage size and the range of that values of integers are different. Okay, so obviously when it comes to the when you are using the integer data type, so just try to make sure, okay, so if you have what is the range of your values, so based on that you restrict your data type to that particular thing, because obviously the storage size differs, right? So if you don't have okay the requirement of having this much of values, so probably okay, so avoid using the big int. Okay, or if you are not having the requirement of this range, basically, okay, you can see the range, the lowest and the highest value which you can use. Okay, so try to choose that smallest whatever the requirement you have, because obviously the performance also impacts here, right? So if you don't have your range may be this values, but you are using the big int, okay, the storage of the it increases, right? So 8 bytes it will occupy. So that's three things in the integer. Okay, so and coming to the decimal, okay, so you have I think this you might be already used in other databases, right? You have used all these data types, means basically the integer and so small serial, big serial, and serial. Okay, so this is basically a kind of sequence. Okay, you have a sequence, right? Okay, so create sequence, so it generates the incremented values. Okay, so this is a kind of data type in Postgres. Okay, so if you use this data type on any column, so there is no need of having again creating extra sequence. That is the advantage of this. Okay, and okay, so you can see here again the storage size is different, and there is a range actually. Okay, so if you go with small serial, the maximum value is 32761, and serial is this, and big serial is this. Okay, so and obviously, so choose whenever you are choosing the these data types. Okay, so always try to choose which try to go with the lower size based on requirement. So if your requirement fits in big serial, don't use I mean in small serial, don't go with big serial. Okay, so go with this small serial only. Okay, so and yeah, because the storage size will always be more, right? So and this is the decimal values. Okay, so you can use all these data types for decimal. So this I think you might have already used. So anyone needs this? Okay, so any kind of anyhow we'll go through some kind of practical things. Okay, so when it comes to the data types, okay, we'll execute some queries. Okay, so there is a monetary data type. Okay, so the data type name itself, it's called money. Storage size is 8 bytes. Okay, so you can use this. So or else, so this is something like you can call this as a integer values only. Okay, so only thing is maybe you'll get the decimal points for this, and you can see the range here. So you see the decimal point after this will be only two values. Okay, so it won't be more than that. Okay, so that is one thing you can you have to be aware of when you are using the money data types. And character data types. Okay, so you have varchar, char, and text. So varchar, I think you might have varchar and char is all same what you have used in the remaining data types. Text is something which is new in Postgres, but text is almost same as varchar only. Coming to the size wise, okay, so it's always, but it's not compatible. Okay, so probably with the other databases, RDBMS. So basically, when you migrate your, I saw this. Okay, so Oracle databases to Postgres. Okay, sometimes some databases it tries to convert to text. Okay, so that's one thing. Byte, yeah. So have you used the large objects in your use cases, lobs? So blobs and globs you might have used in, I think in Oracle we have globs and blobs. So here also Postgres supports the large objects. Okay, so you have the character large objects and blob. Blob is something like your byte only. So how you store your image files in if you are in Oracle or if it is a SQL Server also, how do you store basically the images in the database? How do you do that? Yeah, so blob data type. So what exactly will be stored in the table actually? Okay, so binary format or so do you put the complete data in that blob or how do you put? Blob is there and there is another thing is B file, I think, right? How the B file works in Oracle. So it's pointed to the external image or external file, right? So just put a file location probably. Okay, so which points to the external location. So you can think byte as something like that. Okay, so it's just a pointer basically. Okay, so byte is okay. You can point to the external image. Okay, which can be stored outside of your database. So timestamp. So yeah, so we have timestamps. Okay, so you can have with time zones and without time zones and just the time and intervals also you can store in your Postgres database. Boolean data types. Okay, so it have 1 byte. So if you see in the Boolean data types, okay, so these are the values which you can store in the columns which has the Boolean data types. Okay, so either 1 or 0. So 1 represents true, 0 represents false, S, no, Y, and true, false, TF. So these are the values which you can store in the Boolean data types. Okay, we have this kind of data types in Postgres related to the spatial data types. Okay, or so, but yeah, so we can go with spatial. Okay, we can use like points like longitude, latitude. Okay, so those kind of things you can store in the geometric data types. These data types you have in Oracle also, spatial data types. Whenever you have to get a specific longitude, latitude, let's say you have the Google Maps, right? So you want to store longitude, latitude of a specific point. Okay, so in that case, so you can create data, I mean, table or column with that specific data type. Okay, so then you can store that value in these tables. Okay, and you can do kind of drawings also. Here you have the circle, polygon, path. So path means here you can give from one location to other location. You can draw some kind of line, okay, or we can also call it kind of path. So those things you can do with these kind of data types. Extension, extra extension is required. We call that as PostGIS, okay, Postgres Geographical Information System. So I don't think the normal native Postgres may support. Okay, so even though it may support the visual type, it may not be visible in the PG admin. So you need to have that extension. So extension is nothing but. So do you know about extension in Postgres? Means have you read anytime? So extension is something like you can call as an extra feature kind of thing. Okay, since it's a open source community, so if you just search for Postgres extensions, you will get a lot of extensions for Postgres. So every person, okay, so who is good in whatever the development is, so they create a kind of extension. Okay, so then you can implement that extension into your database. Just like for example, okay, in Postgres, you will not have by default storing the information of the historical statement. Okay, like in Oracle we have AWR, right? So if you take the AWR or history tables, DBA hist tables, if I want to see, let's say you have run the query now, okay, and as a developer maybe you are seeing that the query performance is slow, and probably the same query might have run very good maybe 1 week back. Okay, so that comparison you have in Oracle using the DBA hist tables, Oracle have some background process where it collects that information in these hist tables, and obviously you need to set up that that retention. So you can compare. Okay, this query how much time it took, how many rows it processed, how much CPU it has taken, what is the plan it has used. So the same information you can compare with the last week. So at last week, what plan it has used, how much CPU it has taken, how much elapsed time. So that comparison you will not get by default in Postgres. So you need to have like extension. So we call as PG stat statements kind of thing. So that's the example. Okay, so if you want to have some extra features kind of thing, so you have to go with the extension. So for this GIS, so we need to have the extra extension, so that we call as a PostGIS, Postgres Geographical Information System. So if you have that extension, so you can get the clear visibility how this looks like. Okay.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.